1, 2, 3.
Încercați să mai vorbiți.
1, 2, 3. Și la dânsii tot sau. Vreau să verific dacă. Este? Este, dar să fie, când să fie vorba, la dumneavoastră trebuie dinamicile totuși de închis. Ori...
Da, din închis de zi. Va fi bine.
1, 2, 3.
Dar nu s-au nimic?
Nu. 1, 2, 3.
Aici arată că se... Așa.
Deschis microfonul. Ecou.
Aseară.
Clar. Good morning, dear participants of the conference, dear guests. We'd like to welcome you at the 7th International Conference on Ecological and Environmental Chemistry 2022, organized in Chisinau, Republic of Moldova. This important scientific event belongs to the series of preceding conferences in this field already held since 1999. The current conference gathered more than 250 scientists from more than 20 countries. Such a great interest is undoubtedly caused by the significant role that ecological and environmental chemistry plays in our life and the mutual understanding that the sound scientific outputs should underline the environmentally friendly development. Today, we will session B, Water Science and Society, will discuss current problems regarding ecological chemistry of natural waters, pollution and self-purification, industrial and municipal wastewater treatment and reuse, modern approach and advanced methods to pollution control, monitoring and prevention, transboundary waters and disaster management, water, sanitation and health, and many others. For this session B, were registered about 60 scientists with 20 oral presentations and 52 poster presentations from many scientific organizations from Armenia, Azerbaijan, Belarus, Brazil, France, Georgia, Hungary, Italy, Moldova, Morocco, Poland, Romania, Russia, Ukraine, Turkey. We are very sorry, but because of the COVID-19 pandemic situation, also the current political situation, we cannot meet many of the conference participants here in Chisinau, but we are very happy that we can meet each other online. We wish you and all of us a successful day and hope that the presentation and discussions to be held will be of real value to all of us. Let to introduce you my co-moderators. One of them is academician Professor Tudor Lupashcu from the Institute of Chemistry. And the second moderation is Dr. Corina Itcuș from National Institute of Research and Development for Biological Sciences from Bucharest, Romania. Now we will start our session with the first presentation entitled Synthetic and Natural Absorbance for Water Treatment and Detoxification of the Human Body, presented by academician Tudor Lupashcu from the Institute of Chemistry. Professor Lupashcu, you can start your presentation.
Începeți să vorbiți.
Da, dați share la...
Care e?
Asta. Și dați share.
Da, vorbiți.
Aici, da? Da, click slide.
Da. Bună ziua tuturor, stimați participanți la cea de-a 7-a conferință internațională în domeniul chimiei ecologice și mediul ambient. Din numele echipei secției B, vă salut și eu și vă zic bun venit online la această conferință. Deci raportul meu este consacrat utilizării absorbanților carbonici și naturale pentru tratarea apelor naturale și detoxificarea organismului uman. Raportul este prezentat în numele colectivului Laboratorului Chimie Ecologică din cadrul Institutului de Chimie și Laboratorul Chimiei Apei. Pe parcursul miilor de ani în natură a fost un echilibru între factorul antropic și uman. Deci era un echilibru, deci cantitatea de gaze de căldură care se degaja în procesele de activității umane erau absorbite perfect de către natură. Deci, din păcate, în ultimii 70 de ani, acest echilibru s-a deteriorat, dat fiind faptul dezvoltării industriei, dezvoltării agriculturii, creșterea nivelului de viață a oamenilor, deci mai multe gaze, mai multă căldură, mai mulți poluanți se formează decât natura e în stare să le absorbe. De aceea, deci, chimia ecologică are o importanță deosebită în soluționarea problemelor de mediu. Rezultatele studiilor, proceselor și mecanismelor de transformare, migrare, descompunere catalitică, imobilizare, absorpție a poluanților organici și neorganici care pătrund în obiectele mediului înconjurător stau la baza elaborării tehnologiilor performante de tratare a mediului ambient. Apele subterane de Republica Moldova alcătuiesc un volum de aproximativ 1 km cub. Conform datelor Ministerului Sănătății a Republicii Moldova, circa 70% din sondele arteziene, apa nu corespunde normelor sanitare impuse de standardele de calitate ce se referă la apă potabilă. Ele conțin cantități sporite de fluor, hidrogen sulfurat, ion de fier, mangan, stronțiu, amoniac, ion de amoniu, metan, etc. Una din problemele de bază în alimentarea cu apă potabilă constituie apele freatice, care circa 90% din ele sunt poluanți cu nitrați, nitriți, amoniac, etc. Și această poluare, din păcate, provine are o proveniență antropogenă. Pe parcursul ultimilor 25 de ani, în Institutul de Chimie al Moldovei, se realizează cercetări științifice ce vizează elaborarea tehnologiilor de purificare a apelor subterane, de hidrogen sulfurat, de ion de metalelor grele, ion de amoniu, nitriți, nitrați, etc. Analiza rezultatelor obținute au permis evidențierea și selectarea unui catalizator pe bază de cărbune activ din sâmburi de persic, pe suprafața cărora a fost impregnat ion de cupru. Utilizarea catalizatorului menționat permite de a oxida ionii de sulfură până la ioni de tiosulfați, sulfiți și sulfați, evitându-se faza de formării sulfului coloidal. Acest procedeu reprezintă o noutate mondială și din aceste motive a fost brevetată. În prezent, cercetătorii laboratorului sunt preocupați de investigații științifice care ar permite obținerea așa catalizatori care ar oxida ionii de sulfură din ioni de sulfați, evitându-se formării altor compuși intermediari. Cum am vorbit, deci una din problemele principale pe care se preocupă laboratorul chimiei ecologice este obținerea cărbunilor activi din materie primă, deci locală. Acest proces se rezide la interacțiunea carbonului amorf din mangal cu dioxidul de carbon sau cu vaporii de apă la temperaturi înalte. Deci, la temperaturi de circa 1000 de grade Celsius. În aceste procese au loc, deci, interacțiunea oxidului de carbon cu carbonul amorf, degajându-se oxidul de carbon în cazul interacțiunii cu dioxid de carbon sau a hidrogen în cazul interacțiunii cu vaporii de apă. Aici sunt prezentate procesele chimici de obținere a cărbunilor activi din sâmburi de persici. Deci, prima fază are loc obținerea mangalului la temperatură de 400-500 de grade Celsius. În lipsa de oxigen se obține, deci, mangalul plus ape pirolignoase, care sunt compuse din o serie întreagă de compuși organici pe care sunt evidenți aici, sunt prezentați. Deci, în continuare, deci, mangalul este supus interacțiunii cu vaporii de apă, la, cum am vorbit anterior, la circa 1000 de grade Celsius, obținându-se cărbunele activ și degajându-se, cum am vorbit, oxid de carbon și hidrogen, care, la rândul lor, se ard, obținându-se căldură care este utilizată pentru a menține procesul termic de activare a mangalului. Procesul de obținere a cărbunelor activ prin activare chimică este mult mai simplu. El se realizează la o temperatură mult mai joasă, la o temperatură de circa 400-500 de grade Celsius, și se reduce doar la deshidratare a materiei prime, deci prin obținerea cărbunilor activi, printre altele, cărbuni activi cu indici de calitate mult superiori față de cei care sunt obținuți prin activare fizico-chimică. Deci, evident că un proces important este oxidarea cărbunilor activi, pentru că în acest caz cărbunii activi obțin două funcții. Adică, în primul rând, rămâne funcția de adsorbant, care imobilizează în porii cărbunilor activi a poluanților, și altă proprietate apare ca schimbator de ioni, pentru că în procesul de oxidare cu diferiți oxidanți, cum ar fi acidul azotic, ozonul, oxigenul, etc. Deci se obțin grupări funcționale. Iată, aici sunt prezentate grupările acide și grupările bazice. În mod special, deci predomină în procesul de oxidare grupările acide compuse din grupări carboxilice, fenolice, lactonice, etc. Deci o să dau câteva exemple de eficacitatea utilizării catalizatorului în bază, că am vorbit anterior, pe bază de cărbuni activ obținut din sâmburi de persici, impregnat cu ionii de cupru. Deci s-a studiat o apă model care conține concentrația inițială de sulfuri de 10 mg la litru și apă reală din orășelul Hâncești, Republica Moldova. Deci, principal, cum am vorbit anterior, și în primul caz și în al doilea caz nu se formează sulf coloidal, ceea ce permite utilizarea catalizatorului o perioadă foarte lungă, pentru că porii cărbunilor activi nu se calmatează prin sulful coloidal. În schimb, se formează, cum am vorbit anterior, tiosulfați, sulfiți și sulfați. Deci, asta e foarte important, pentru că deci, acest catalizator nu permite obținerea sulfului coloidal. În principiu, acest proces poate fi redat prin următorul mecanism. Deci, cărbunii activi, cum am vorbit, este supus oxidării, se formează, cum am vorbit, deci, cărbuni activi oxidați cu care se conțin diferite grupe funcționale. La interacțiune cu o sare a cuprului se formează compuși cuprului pe suprafața cărbunilor activi prin mecanismul de schimb ionic sau prin mecanismul de formare a compuștilor coordinativi. Și iată, acest în principiu este catalizatorul de care am vorbit. La barbotare cu aer, oxigenul din aer, deci interacționează cu acest cărbune activ, cu ionii de cupru, formându-se deci, radicali liberi. Și iată, acești radicali liberi tocmai au acest rol de a oxida ionii de sulfură din soluții reale și din soluții model. Deci, în cazul nostru, am luat o sare de sulfură de sodiu, care, deci, la interacțiune cu acest catalizator, sulful se oxidează până la sulf 6 valent. Și un caz, deci, când cărbunul activ nu are acest ion de cupru impregnat. Deci, în acest caz, cum vedeți, se formează sulful coloidal, care calmatează porii cărbuni activ oxidat și foarte repede acest cărbune activ oxidat își pierde capacitatea de catalizator. În continuare voi prezenta câteva rezultate reale obținute de colegii mei din cadrul laboratorului chimie ecologică în diferite zone geografice ale Republicii Moldova. În acest tabel sunt prezentate calitatea apei subterane din comuna Scoleni, raionul Ungheni. Și vedeți că aici, deci, conținutul de ionuri de fier total este de vreo 4 ori, norma e 0,3, real e 1,39, adică de 4 ori și ceva mai mare decât norma admisibilă și, de asemenea, de 9 ori e mai mare concentrația ionurilor de mangan. Și această apă, ea, când o scoatem din sondă, e foarte limpede și foarte străvezie, însă în timp, în contact cu aerul, fierul bivalent se oxidează până la fier trivalent și manganul bivalent se oxidează până la mangan patrovalent, ceea ce formează precipitat și apa devine tulbură, are o culoare neagră. Deci noi în laborator am elaborat o tehnologie care permite, deci faza inițială, deci apa este alcalinizată, apoi prin aerare cu aer, deci cum am vorbit anterior, manganul și fierul se oxidează, respectiv fierul până la trivalent, manganul până la patrovalent, precipitatul se depune precipitat, apoi apa se este filtrat prin nisip, în care are loc separarea finală de particule de oxid de fier, hidroxid de fier și hidroxid de mangan și, deci, apa purificată este transmisă populației pentru utilizare. Această tehnologie cu succes a fost implementată în comuna Sculeni, raionul Ungheni. Alt caz de succes a fost tratarea apelor din Hâncești, care au o concentrație de sulfuri foarte mare, deci de 80 de ori mai mare decât norma și de 8 ori mai mare concentrație de amoniu în aceste ape. Deci este necesară o tehnologie specială pentru a elimina acești compuși din apele subterane din raionul Hâncești, din orășelul Hâncești. Deci noi am elaborat o tehnologie de oxidare, de eliminare a amoniacului și respectiv și a hidrogenului sulfurat, care se reduce prin tratarea acestor ape cu hipoclorid de calciu și deci după tratare, deci amoniacul se oxidează până la azot gazos. Apa după asta este trecută prin cărbune activ pentru eliminarea altor componente care pot să fie obținute în cadrul oxidării cu hipoclorid de calciu și în rezultat se obține o apă destul de bună, care nu conține ionii de sulfură și ionii de amoniu. Deci a fost studiat de asemenea și activitatea catalitică a diferitor catalizatori pe bază de cărbune activi, impregnați cu oxizi de mangan și săruri de cupru. Deci prin metoda chemiluminescenței în sistemul luminol peroxid s-a stabilit activitatea prooxidantă a acestor catalizatori și s-a selectat acei catalizatori care au o eficiență destul de pronunțată în eliminarea din ape a ionurilor de nitriți. Deci, în laborator a fost construită de către un cercetător pe Ducov o instalație semipilot mobilă de tratare a apelor naturale. Ea e complexă, întrunește mai multe faze de tratare, printre alte aerare, oxidare, deci după aceea absorbție pe cărbune activi, schimbători de ioni și în final, dacă este nevoie, și osmosă inversă. Deci asta, cu ajutorul acestei instalații, în ultimii ani am reușit să elaborăm tehnologii performante de tratare a apelor subterane în diferite zone geografice a Republicii Moldova. Și să vă prezint câteva exemple. Deci, iată, aici avem apa subterană din comuna Pănășești, raionul Strășeni. Vedeți, aici e prezentată valoarea admisibilă și valorile deci, depistate. Și vedeți, în 7 poziții, deci apa nu corespunde normelor sanitare. Iată aici, deci 7 poziții depășesc concentrația limita maximă admisibilă, rezidiu uscat, ionii de amoniu, sodiu, ion de fluor, ion de fier și oxidabilitate și hidrogenul sulfurat. Iar pentru parametrul duritate, valoarea depistată este sub normă. Deci, aici sunt prezentate de asemenea calitatea apelor din comuna Coșcodeni, raionul Sângerei, și cu roșu tot vedeți cantitatea de indici care depășește cu mult de 10, poate și mai multe ori, normele admisibile și cu ajutorul acestei instalații am reușit să obținem o apă potabilă cu de calitate înaltă. Iată, aici sunt prezentate, deci, calitatea apei după tratare la instalația semipilot pe care am prezentat-o anterior și observați că indicii de calitate practic nu depășesc cei admisibili pentru apă potabilă. Cum am spus anterior, în laborator avem și preocupări de a utiliza, de a obține, mai corect spus, cărbuni activi pentru detoxificarea organismului uman. Asta e o problemă foarte importantă, pentru că, din păcate, în farmaciile, cel puțin din Republica Moldova, noi nu avem cărbuni activi care ar avea calități impuse de monografie farmacopeică europeană, în mod special la capacitatea de absorbție cu felazonă, și însă cu colectivul Laboratorului Chimie Ecologică a reușit prin sinteză specială, prin metodă specială de sinteză cărbunelor activi prin strat fluidizat, să obținem 2 cărbuni activi obținuți din lemn și din sâmburi de caise, să obținem 2 absorbanți care corespund normelor impuse de monografie farmacopeică europeană ediția 10. Și acești cărbuni activi pot fi cu succes utilizați în calitate de interabsorbanți pentru detoxificarea organismului uman. Iată echipa care a colaborat. Din păcate, unul dintre dânsii, Vasile Rosu, Dumnezeu să nu mai este între noi. Vă mulțumesc pentru atenție.
Dear professor, thank you very much for your presentation. Please, audience, if you have any questions, we are waiting. Any questions, please?
Yes.
Thank you again. If you have any questions, we move to the next presentation by Dr. Corina Itzpuș from National Institute of Research and Development for Biological Sciences, Bucharest, Romania, which will present the next presentation.
Hello, everybody. Good morning.
Hello.
Let me share my. One moment, because I have a problem. Okay. Do you see my presentation?
Yes, we see your presentation.
Okay. I will present our thank you for introducing me, first of all. I will present our analysis regarding physicochemical and microbiological assessments of waters and sediments from Danube Delta. Aquatic ecosystems are critical components of the global environment. So one of the most important issues that has not been elucidated in aquatic ecology concerns the long-term effect of climate change on the ecosystem stability. Due to the role it plays in aquatic ecosystems, understanding how microbial communities respond to climate change is a major challenge. Our investigations focused on the microbial diversity in water and sediments from Danube Delta in relation with the spatial distribution and geochemistry. The samples for this study were collected during 2 seasons, warm and cold, from 11 sites that cover all the important regions in Danube Delta. For all the monitored lakes, the concentrations of total organochlorine compounds varied between 0.2 micrograms per kilogram and 46 micrograms per kilogram. Of the monitored chlorinated organic compounds, the highest concentrations were determined for the isomers hexachlorocyclohexane and polychlorinated biphenyls. The low values of PCBs in the collected samples from Danube Delta may be due to the fact that these compounds have been used long time ago in Eastern Europe. So in the most lakes, the concentrations of hexachlorohexane isomers were on the average less than 0.2. While in 2 basins, Kara-Orman and Lake Krishan, the concentration of lindane pesticide was higher, reaching a concentration of 35 micrograms per kilogram. High concentrations of the HEH isomer indicate the potential use of lindane insecticide in the Danube Delta watershed. In contrast, low values of DDT compared to those reported by others suggest that the insecticide is no longer used in the investigated areas. There were registered low levels of DDT and HEH in the sediments of the Danube Delta, and as I told you, are most likely due to the past use of these from agriculture and atmospheric deposits. Statistically significant correlations were identified for isomers of hexachlorocyclohexane, polychlorinated biphenyls, and metabolic products of DDT. In order to investigate the alpha diversity of microorganisms, several indices were calculated as Simpson, Shannon, and Chow. In general, regardless of the calculated index, the samples collected in the warm season had a higher diversity, as you can see in the graph, with the exception of the samples collected from Periprava and Krishan, which showed a higher diversity in the cold season. The indices had the lowest values in the samples from Krishan locality, and the most drastic variation between the cold and the warm seasons were identified in the samples from Taranova Lake. Murghiol samples showed that the highest values for Simpson and Shannon indices, but not for the observed number of species, which indicates a uniform distribution of taxonomic units. Environmental factors that have been correlated with beta diversity, you can see them in the graph that are marked by arrows. The June sample from Sfântu Gheorghe Palade is separated from all the other clusters, as well as the sample from Krishan. It is possible that certain taxonomic groups appear in these samples with a much higher abundance than the other samples, with exception of the one from Pardina and Periprava. The other samples seem not to differ significantly. Conductivity and nitrate concentrations are correlated with beta diversity metrics. These two parameters reach the highest values in the samples Sfântu Gheorghe Palade, the conductivity having values of 60 microsiemens per centimeters, while the other samples have between 300 and 400 microsiemens. Okay, the vast majority of the physicochemical parameters measured don't appear to influence the number of species present in their distribution. The only negative and significant correlation is between the concentration of ammonium and the diversity indices. Also, the negative effect of high ammonium levels is known for stopping the microbial growth as well as for plants and animals. The toxic concentration in the literature are much higher than in the sludge samples we analyzed. In addition, it has been shown that the ammonium, even in molecular concentration, does not directly inhibit bacterial growth. In our case, even at concentration between 6 and 130 milligrams per kilogram, ammonium seems to have a negative impact on our diversity. Spearman correlations between alpha diversity and pesticide concentration show that the most pesticides do not significantly influence microbial diversity. Hexachlorohexane is the only exception, the pesticide being negatively correlated with the alpha diversity parameters. Degradation of different isomers by various microbial consortia has already been demonstrated. This negative correlation between alpha diversity indices and insecticide isomers could indicate that the diverse microbial community has a metabolic pathways necessary for degradation, the mineralization of these pesticides. Analysis of gene encoding 60 sRNA indicated the presence of 17 bacterial clusters in the 11 sampling points, while a relative abundance of less than 1%, with a relative abundance of less than 1%. No seasonal variability was detected, while the main community members in all 11 trials being affiliated with Firmicutes and Proteobacteria. However, in the cold season in October, there was an increase in the relative abundance of Firmicutes from 50% to 60%, while Pottery and Tenericutes were present in relatively high abundance at the Gura Dunavăț point, and the Bacteroidetes in Sfântu Gheorghe Palade channel. Only at the Crișan sampling point, as you can see in the graphs, Proteobacteria has a higher relative abundance of 69.8 than Firmicutes. Based on the inverse correlation with the pesticide isomers and metabolic products of DDT, Chlamydia, Depente, and other phyla may be sensitive to this toxic sediment compound. Sensitivity to pesticides may be also be manifested by Epsilon bacterarchaeota related bacteria that correlate negatively with PCBs and HEH isomers. In contrast, statistically significant negative correlations were observed for Chlamydia, Omnitrophicaeota, and Pathecibacteria. What is also already known about these microorganisms is that some are pathogenic species and others have a small genome that gives them functional limitations and a predisposition to a symbiotic lifestyle. All these characteristics predispose them to sensitivity to the toxic effect of ammonium ions on their own cells or on the cells they parasite or with which they live in symbiosis. Regarding possible correlations between sediment microbial diversity and pesticides concentration, positive correlations were calculated between Bacteroidetes, Planktomicetes, and Proteobacteria and insecticides, suggesting that members of these clusters may be unaffected by the presence of this pesticide in the environment. Statistically, significant negative correlations were calculated for Firmicutes and pesticides, and are recognized having the ability to degrade organochlorine pesticides. In conclusion, the physicochemical analysis performed for each site indicates the presence of reduced quantities of organochlorinated compounds in the most of the analyzed samples, a high content of lindan insecticide, respectively the isomer beta lindan insecticide and PCBs were measured in Kara-Orman and Krishan sampling points. With the sequencing of 16S RNA gene carried out on the samples, highlighted variations of bacterial diversity with the type of habitat, location, and geochemical characteristics. The microbial communities consist of several bacteria phylum, of which Firmicutes, Proteobacteria, Actinobacteria, and Bacteroidetes being the most abundant. There was no detected seasonal variability, and the main community members were affiliated with Firmicutes and Proteobacteria strain. An increase was observed in the cold season, while in the warm season, Bacteroidetes and Proteobacteria were higher with a relative abundance in other sites. Associations between this microbial diversity and the pesticide content indicate the possibility of a link between community structure and the presence of organochlorine pesticides. Thank you very much.
Thank you. Thank you very much for your presentation. Very interesting presentation. Please, if you have questions, please, audience, if you have questions.
I have a question.
Please, you can speak on okay.
Okay, so my question is, if you find a decline in concentration and some transformation of investigated compounds from up to downstream of the river.
Yeah, we observed a decline, but in the areas where the effluents meet. So I think it's because the water mixes, so dissolves the compounds. And also, yeah, in the upper stream, there were higher concentrations, and I think it's due what the Danube brings at the entrance in Danube Delta, and there are the higher deposits of pesticides and organochlorinated compounds.
But microbial community, I mean, the same from up to down.
It's relatively the same. The community, the diversity, it's relatively the same, but the phylums we analyzed differ in percentage. So upstream Firmicutes is one of the most predominant, while inside of the delta near the seashore, to say so, Bacteroidetes is another that is predominant, so it separates the diversity, to say so. So yes, there is a difference between.
Thank you.
Thank you.
Thank you very much.
Thank you.
Other questions, please? If no more questions, thank you once again for your presentation, for answers. Also, we invite you to collaborate with the Institute of Chemistry for research.
Thank you very much.
So the next speaker is academician Vladimir Tsitsishvili, from Georgia. I don't know if academician Tsitsishvili is with us, but I'm afraid they're not. He's not with us. So, if maybe he'll connect later. So we will move to the next communication presentation by Dr. Tamer Adnan Abdullah from Hungary. Was? No?
Есть.
Good morning. Hello.
Please, you can present your communication.
Okay, I will let me share my screen. Can you see my presentation?
Yes, yes.
Okay. First of all, my name is Tamer Adnan Abdullah. I am working in University of Pannonia, and I would like to thank the organizing committee to give us this opportunity to present our work, new nano-size materials obtained by thermal treatment, prepared by different annealing temperature for dyes removal from water. We will talk about, we will introduce the problem, and for water treatment, then the main objective of our work, and we will speak of about the preparing the material with different annealing temperature, then successfully characterization and study the adsorption capacity and removal efficiency of methylene blue from water, and we will describe the mechanism and the best kinetic model and equilibrium isotherm model. Then we will summarize our work. Various industries and manufacturing of dyes, papers, tanners, cosmetics, coffee plumbing, pharmaceutical, they spew out the byproducts, and this dyes should be removed. It's affected our environment and the ecosystem, and different techniques used, and the adsorption, one of the best and the cost-effective techniques. And a very good adsorbent material is metal oxide nanoparticles, can be easily used with costly effective, because nanomaterials we can use very little amount and give the high efficiency and capacity. The objective of our work to prepare the nanosorbent based on vanadium pentoxide, and we prepared in different annealing temperature, and then we characterize these nanomaterials, and we study the removal efficiency and the absorption capacity, and we study the optimum parameters, different range of times, dose and temperature of solution. Then we study also the best models, kinetic models, and also equilibrium isotherm, and we describe the proposal mechanism for our adsorption. This diagram shows the steps of preparing vanadium pentoxide. We use nitric acid, and then filtration the solution, as you can see the steps, and then by hydrothermal treatment by reflex. Finally, after we prepared the vanadium, then we annealed the vanadium itself different annealing temperature, and we study the different annealing temperature affected in the adsorption process. So this is the steps of preparation of vanadium, and very important is the pH, because when we add the nitric acid, when it's more pH affected in the particle shape. Let's talk about the characterization. This figure shows the XRD pattern for different for vanadium with different annealing temperature preparation. So it has been very clear when we increase the annealing temperature, the peaks which is related to the orthorhombic crystallinity phase more intense when we increase the annealing temperature. And FTIR for as prepared vanadium with the H2O, then we increase the annealing temperature. As you can see, the peaks which is related to the H2O, which is in the between the layers of vanadium, has been disappeared when we treat with high temperature. UV visible spectroscopic also shows that when we increase the annealing temperature, the energy gap has been different. It means that the vanadium change its crystallinity to survive the temperature. So also disagree with the XR. And TG was done for the fresh vanadium prepared. So it shows that approximately 4 stages. The first stage up to 100 degrees, it is just for removal of moisture. Then up to 220, it shows that the removal of water between the layers. Then the impurities after up to 420 degrees centigrade, which is related to the removal of CTAB, which was the surfactant in the reactor, citraminium bromide. Then after 420 up to final more than 800, the vanadium stay in its stable crystallinity phase. Atomic force microscopy for as prepared and annealed with different annealing temperature shows the average grain size and the 3-dimension picture of particles, and the average grain size was in nanoscale, as you can see from the table. Field emission scanning electron microscope has been done for vanadium prepared at 500 degrees centigrade with the different scale, and it shows very clear it is in nanoflakes shape. This shows the adsorption work process. First, we prepare the stock solution and we study, we use UV visible to study the removal efficiency and absorption capacity, and we study different range of to study the optimum parameters, range of time, and the temperature, absorbent dose, and we study the removal efficiency of methylene blue from water. And also we applied the first and second order models to study the kinetics, and also Langmuir and Freundlich to describe the equilibrium isotherm. Langmuir to see if it is monolayer adsorption, and Freundlich if it is more than layer. Let's talk about the adsorption removal efficiency and adsorption results. This two figures shows the decrease in concentration of methylene blue with time, and the figure on the right side shows the removal efficiency with the time, and it shows the lowest concentration of methylene blue and highest removal efficiency achieved when we use vanadium annealed at 500 degrees centigrade. And the optimum time, it is after 40 minutes. And here we study, we select vanadium at 500 degrees centigrade, and we study the different dose, and shows that the best dose was 60 milligram, and the temperature of solution, when it increased, the removal efficiency also was increased, and the optimum temperature was 45 degrees centigrade. And here is the removal efficiency and absorption capacity of vanadium annealed at different annealing temperature. It shows that vanadium at 500 degree is achieved 27 milligram per gram, and it's applicable as compared with the literatures. We study the kinetic and isotherm equilibrium models to see our best model, and it shows that pseudo first and second order models, the pseudo second order models describe the best kinetic model, and also friendly isotherm describe the best isotherm with highest correlation number. This slide describes the mechanism proposed for vanadium adsorption of methylene blue from water. As you can see from the figure, it could be ionic bond happen between positive sulfur and methylene blue and negative oxygen in vanadium. And at the same time, vanadium can absorb another molecule by coordination bond between electron pair of nitrogen and vanadium atom positive. So it could be each molecule of vanadium can absorb more than one molecule of methylene blue. We can summarize our work. The nanostructure of vanadium prepared with different anionic temperature confirmed by XRD, AFM, and SEM. Also, we confirmed the decomposition using TG and FTIR. XRD also represent the crystallinity, and it shows that when the temperature increased, the more orthorhombic crystalline phase was appeared. And also we summarize the optimum parameters for methylene blue removal from water, and it shows that the best sample was vanadium prepared at annealed at 500 degrees centigrade, and the volume was 30 ml, concentration 20 milligram per liter of methylene blue. The time was 40 minutes, and the temperature of solution 45 degrees centigrade, and the absorbent dose was 60 milligram. It was found also that the kinetic, the second order kinetic model, and also friendly equilibrium isotherm model was the best with the highest correlation number. I would like to thank you, and a special acknowledgement to my professor Ridaya Akosh, which he is the head of our group, and we lost him unfortunately in this at the end of 2021, unfortunately. And a special thank for Professor Igor and Technical University of Fiash. He is also, I would like to thank him for his help and support, and also Professor Rashid Nirak. Thank you so much. And is there any question?
Thank you for your presentations. Please, questions. If you have questions, please. Any questions for our audience online? If no one question, please, Dr. Abdullah, we thank you very much for your presentation. Also, we invite you to collaborate with researchers from Institute of Chemistry and our institutions from Republic of Moldova, of course. Thank you once again.
Thank you.
And now I would like to ask Dr. Corina Ispush to moderate the next presentations, if it's possible. Okay, we'll move to the next presentation. Next speaker is Vladimir Prozorovich, Institute of General and Inorganic Chemistry of the National Academy of Sciences of Belarus, with the presentation, synthesis, structure, and absorption properties of ion exchange materials based on lithium titanium spinel. You can wait for some seconds. Mr. Prozorovic, are you with us? So we can move to the next presentation. I see with us is Professor Titevan Kupatadze. So I would like to give you the floor, present your presentation entitled Water and Society in Georgia from Historical Angle. Please,
Hello,
Professor.
hello everyone. Yes, I'm with you, and greetings, many greetings from Georgia. And now I will share my presentation. Can you see it?
Yes, we see your presentation. It's okay.
My today's presentation is a bit overview, and I will talk regarding water and society in Georgia from historical angle. Georgia is rich in water resources. There are more than 26,000 rivers in the country, belonging to the basin of Black Sea and Caspian Sea. Among them is a watershed Lihi Range. In most cases, rivers in western Georgia have independent catchment. All the rivers in eastern Georgia belong to the Mtskheta River basin. The Pottery River is the main and the longest river in the South Caucasus. It is 351 kilometers long within the borders of Georgia. Most of the rivers are fed by rain and melting snow waters. And in these two pictures, you can see river maps of Georgia and Pottery from the most spectacular point of view from the ancient capital of Georgia, from Mtskheta. The longest river of the country is Alazani. In this right side picture, you can see Alazani with the length of 407 kilometers and the most affluent Rioni on the left side. It originates in the Caucasus Mountains, eventually joining the Black Sea. There are 856 lakes and more than 40 reservoirs in Georgia. Lakes differ by origin, shapes, depth, size, body, and significance. Most of them are concentrated on the Java-Kheti volcanic plateau in southern Georgia. In ancient times, Palyastomi Lake used to be the bay of Black Sea and was later separated from it by a strip of sand. You can see these are top pictures of Palyastomi Lake. This is a very important lake for Georgia nowadays as well. The maximum depth of Palyastomi Lake is 3 meters, due to which a large part of the lake is covered with vegetation and various fauna is observed in this vegetation. There is an abundance of fresh as well as mineral and thermal groundwaters in Georgia. Fresh groundwaters are unevenly distributed in the country. The number increases from east to west. Fresh groundwater is highly important for the supply of population with potable water. There are about 2,000 mineral springs in Georgia, distinguished by their composition and characterized by healing properties such as world-known Borjomi, Sairme, Nabeglavi, Ustera, Lugela, and other mineral waters. Resorts have been built on them. Among groundwaters, most distinguished by their healing properties are Altubo thermal water and Tbilisi sulfur hot waters. From a regional viewpoint, all water resources are of importance. For example, Alazani River in Kakheti region, and Kakheti region is famous for wine production, is used for irrigation. Part of the population in Western Georgia use Rioni River for irrigation, the old name of which is linked with Greek language Phazisi. Surface water contamination by waste and irrigation water use represent the major issues in the country. Water pollution is driven by human activity. It comes from point and non-point sources. Point sources include municipal waste from cities and settlements, industrial waste, waste from hospitals, recreation, and other health centers. Non-points, surface waste from agriculture fields, storm runoff from cities and landfills. Municipal waste from cities and settlements pollute water with organic matter, nitrogen, and phosphorus compounds. Among the most polluted rivers can be mentioned Mtwari, Vere, Alazani, Algeti, Suramela, and Rioni. By the way, as I mentioned, Alazani belonged to Kakheti region, and in the poster session, there is my second presentation where we studied drinking water in some villages in Kakheti regions. There are centralized sanitation systems in 45 cities, among which 33 are equipped with the treatment facilities. The latter were built in 1972, 1986, and mostly are out of operation. The rest work unsatisfactory. Unfortunately, biological treatment is practically absent. Most polluted rivers in Mtwari River basin are Mtwari within Tbilisi and Rustavi, and the main pollutants are oil products, phenols, heavy metals, Mashavera, it's zinc and copper ions, and Mashavera is used for obtaining some golds, and zinc and copper ions, they are trace elements in this case. In the Black Sea basin, Quirilla, oil products, and manganese ions, Rioni and its tributary Ogaskura, oil products, zinc and copper ions, Tribuli, mechanical pollution from a coal mining industry, Kubistrali, oil products, Luhumi, arsenic ions. The following categories of surfaces water bodies are established for water uses. The first category, water bodies used for drinking purposes. The second category, water bodies used for recreation. And the third one, water bodies used for fish breeding. For each category, 5 quality classes are defined. The first class, very good quality, it has a blue color, pure oligotrophic water in natural conditions, insignificant anthropogenetic pollution is allowed. Water is characterized by stable, high concentration of oxygen close to full saturation, low concentration of bioorganic elements and bacteria facilities, salmon breeding, protective water potential is very high. Second class quality is good, has a green color, insignificantly polluted mesotrophic water, certain amount of organic matter from wastes after treatment is observed. Water bodies are well saturated with oxygen all year round. Protective potential is well maintained. Inflows do not contain harmful matter. The third class water quality is satisfactory, yellow color, temperature eutrophic water containing insignificant amount of organic matter and bioorganic elements. Sometimes a lack of oxygen is possible. Protective potential is weak, pollution with harmful matter and microbes. Concentration of harmful matter varies from natural to toxic level. The first class water quality is unsatisfactory and has orange color. Eutrophic water is significantly polluted, contains organic, bioorganics, and harmful matter. Sometimes lack of oxygen is possible, organic matter destruction of settings facilities, anaerobic process, and cause fish perishing. Pollution exceeds protective potential. Microbes do not allow the water body to recreate. Harmful matter negatively impacts flora and fauna. And fifth class water quality is bad, has a red color, very high polluted hypertoxic water. The main problems is associated with oxygen regime, when lack of oxygen causes anaerobic process. And I will pay your attention to these two pictures. This is from my one project. We just working in this project. This is a remote sensing, and these pictures are made from Sentinel-4 and 5, and we study historical changes of chlorophyll, e.g. eutrophication processes of Black Sea border and lakes and nearby rivers. And these pictures are made from 2020 June, and you can see this is a Black Sea border near the Pottery. This is near Batumi. This is a Paliastomi Lake, and this is a Rioni with its two tributaries. And you can see a very high level of chlorophyll, e.g. eutrophication process is very high. Now, very shortly regarding all the irrigation systems and traditions of their management, Georgian cities of antiquity had proper irrigation systems. Among them, Old Mtskheta, which was the ancient capital of Kingdom of Kartli. There were many agricultural workshop settlements around Mtskheta using a single irrigation system. Apart from Mtskheta, irrigation and drinking water supply systems were observed in other cities as well, Samshulde, Hunan, Uplistsihe, and etc. The Alazani Canal was a very huge canal, which was stretched for 119 kilometers and irrigate 53,000 hectares, was led to irrigate large areas. The canal is led with the high engineering skills for this time. It is not cut at any place. The Alazani Canal almost meet modern engineering requirements. Furthermore, for soil scoring prevention, the Alazani Canal was drilled at relatively wide and less depth, which significantly reduced the water velocity, and nowadays is also active. The Alazani Canal is dated back to the 12th century by the scientist, and is associated with the name of King Tamar, you can see in the picture, according to folk tale. Some of the canals are probably much older. Some may include the results of Tamar's royal activity. But if we understand Tamar as a synonym of economic prosperity and the strength of federal Georgia, considering the folklore origin of this report, then we must recognize this tradition as a historical fact of general and conclude that the construction of large canals is an indicator of the great prosperity of federal Georgia. The fact that construction of large canals was one of the concerns of Kingdom of Georgia is well documented in the 9th century historical work Muktsevai Kartlisai, conversion of Kartli, and by the 11th century historian Leontim Rovelli. The construction of the last large irrigation canal is federal in federal Georgia, belongs to Erekle II. You can see This is in Tel Aviv, in this own city, in Kaheti also. This is an irrigation canal to the Iori River, designed for Samgori Valley irrigation. This is a picture of Iori River. The length of the canal is 20 kilometers. All the villages using the irrigation systems were involved in its construction. Nowadays, in line with Georgia legislation, water resources are property of state, which gives license for water use. There are 24 irrigation water reservoirs, which are also sources for irrigation. Major reservoirs are Sioni, Tbilisi, Algeti, Zonkari, Jandari, so they are the main reservoirs. What about drinking water supplies? Tbilisi rich in medicinal sulfur water, was poor in drinking water in all this time. Due to the saltiness of the wells and the scarcity of springs, the old Tbilisi dwellers mainly used them quarry river water for drinking. In this period of time, according some historical sources, Quarry River does not was polluted like nowadays, but it's very important that in the 18th century, our chemist king, King Wachtang the Sixth, and it's very important because this was a Georgian king who wrote chemistry manuals. You can see in this picture the extract from its book, and he did itself the experiments in his laboratory. According to the history of chemistry, there was a second king also, Spanish king, Philip II, who also, like Wachtang, but he was from 14th centuries. Like Wachtang, he worked at the laboratory. Other kings, they are interested in chemistry, but of course, they gave just money for scientists, alchemists, and after medieval chemists. So King Wachtang in his book describe water purification with plants like Ibn Sina, Avicenna. Avicenna first time wrote in this medicine tractate that some plants can be used for water purification, and the same is we can read in the book of mixing oils and making chemistry by Wachtang the Sixth, and quarry was purified according to the Wachtang methodology in the 18th century. The 13th century rock-cut town in Vardzia had interesting construction. The city was mainly supplied with river water. However, the remains of paved path leading to nearby springs have been found, as well as a tunnel leading to the river, which was used during the siege of the city. A trench was dug under the tunnels where water pipes were laid. If the enemy accidentally discovered the tunnel, and Georgia has a lot of enemies in that period of time and nowadays also, he would not even start searching for the water flowing under it. More than 400 caves have been discovered in Vardzia. Utensil, so you can see a traditional Georgian pottery, and what is the most important for pottery production, they use the ceramic and clay. So they never used, for example, some kind of heavy metals, right? Like old Rome Empire and other countries. And that's why drinking water in this vessel always was stayed very healthy and good for drinking. There is some description of medieval pottery. They was like Byzantine design and Greece design also was observed. And you can see here in this slide also, this is a first one which was found in Skonhelti Valley by archaeological researching. And this is a nowadays pottery. What about old beds? Tbilisi sulfur beds are especially well known. Sulfur hot water is also associated with the legend of Tbilisi Foundation, according to which a pheasant flew to King Vakhtang Gurgasali while hunting in third century. This is a used for medical point of views, for joints, for example, is very good for body purification. So as conclusion, the use of water resources for agriculture and household purposes has an ancient tradition in Georgia. Particularly noteworthy are the irrigation system, oldest fragments of which date back to the Bronze Age. Later in antiquity, the federal era, the scale of irrigation farming and respectively as a network of irrigation canals, as well as the construction and management technologies developed significantly. It should be noted that terrain characteristics, soil structure, climate were always taken into account when constructing and maintaining irrigation systems. Taking care of drinking water healthiness, in addition to medieval knowledge, also required knowledge of water chemical properties. In this regard, not only the old folk traditions of water purification are important, but also the rules of drinking and storage utensil production, considering the shape of utensil, which help to call the water settle harmful impurities, and the bottom of utensil and isolate them from drinking water. So thank you very much for your attention, and let me say that I'm very, very happy that I'm today with you. Thank you for watching me, listening and participate here.
Dear Professor, thank you very much for your presentation. We also are very, very happy to see you again, even online, but at our conference, because as I know you, you participated in the last conference in Chisinau.
And I hope that better time is ahead.
I remember you. Yes. So thank you again for your presentation about water sources, history, and Georgian traditions regarding water. So I ask audience if you have.
I see Elena Kornilova, dear Elena. She has a right there.
Yes.
Maybe she won't ask some question because he.
Yes. Who have questions? Please, you can write on chat also questions. But till now, I don't see any questions.
Okay.
So thank you again.
Thank you very much.
Thank you very much. We will wait to see you in Chisinau again.
I am also will waiting this better time.
Yes. Okay. Thank you. So, dear participants, according to our agenda, we will have a break in our program for coffee or tea. After break coffee, moderators of the session B will be Professor Maria Gonța, Moldova State University, Moldova, and Professor Constantin Bulmaga, Institute of Ecology and Geography, Moldova. So we will have a break till 11:30.
Хорошо, вот я сейчас включил. Теперь демонстрация экрана. Так, что дальше? Ну вот они там, тут дальше что такое.
Ну, где презентация ваша?
Вот презентация.
На нее надо кликнуть один раз. Нет, нет, вот в этом открытом окне, видите? Левый
Да я
нижний угол.
вижу,
Вот,
я
сюда.
не вижу, где это.
Кликните один раз. И теперь в правом нижнем поделиться. Нажмите. Нет, этого же вот маленького окошка. Да, вот, поделиться.
Угу.
Только можно первую надо как-то страницу.
А как же первую страницу мне показать?
Это у вас первая страница. Или нет?
Зачем?
Не-не-не.
У меня первая страница должна быть вот она.
Тогда стрелочками.
Вверх, стрелочка.
Стрелочкой влево. Влево.
А мышка? Или F5 надо, как не работает.
Ну, надо вот там. Нет.
Я же поэтому вам говорю, что мне первая вот эта страница.
Ну, вот.
Так, а и дальше что? И дальше влево?
Нет, теперь вправо. Происходит. Вниз.
Вверх. Вниз.
То есть вверх-вниз. Тут переключение.
Вообще не работает.
Ну,
Работает, но
там
с задержкой. Там очень большие файлы фото, поэтому оно, ну, надо один раз кликнуть и ждать.
Так,
Включается
теперь,
секунду.
значит, как мне выключить? Зачем мне это делать? Как мне? Я должен с ними поговорить.
Вы
Выйти вот как сейчас?
Вы также с ними общаетесь, я не знаю, вот вы.
Вы хотите видеть то, что там происходит?
Вот.
Я хочу поговорить, потому что они-то объявят Иванца. Я хотел бы сказать, что мне нужно с ними
Давайте
переговорить.
остановим демонстрацию.
Вот я об этом тебя спрашиваю. Как обстанавливать демонстрацию?
Ну, Коля уже остановила его.
Знаешь, Коля, ты не...
Коля будет тут у нас спасет.
Да. How his name? Ага. I'm sorry. Мария Гонта.
Да.
Добрый день. Я могу по-русски с вами говорить или нет?
Здравствуйте, да, можете со мной поговорить.
Это академик Агабеков из Минска. Я по поводу нашего доклада с господином Иванцовым.
Да.
Значит, ну, вместо него этот доклад я буду делать, если можно.
Вы будете, да?
Да. Там он в программе есть, там, он написан там в программе.
Да, сейчас. Минутку.
Да, мы знаем.
Да.
И я с
Господин
вашего...
академик, мы очень
Академик
рады вас
Агабеков.
видеть.
Да, я был у вас. И я, с вашего позволения, если можно, сказал бы несколько слов поздравительных господину Дуке, Георгию Дука. Это можно
Пожалуйста,
сказать?
please.
Можно, да?
Можно.
Ну и все. Ну, я не переберу время, я это сделаю за счет доклада нашего. А вот это я что-то вот я смотрю на Булимага, по-моему. Вот это я где-то этого товарища видел. А скажите, пожалуйста, вот это профессор Булимага или академик, да? Мы с вами встречались или нет?
Может быть, и...
Я думаю,
У нас
что
было
мы
много
встречались.
конференций.
Я был же, наверное, где-то встречались, потому что знакомые. Наверное, встречались. Хорошо, ну спасибо. Я с вашего разрешения буду делать. Ну, так все, Коля, можно тогда отключаться пока, да?
Можно пока звук просто наш выключить.
А во сколько? Уже 12:30?
Ну, они скажут мне.
Good morning. Здравствуйте. Last presentation. Next presentation. It's controlled synthesis and properties of mesoporous heterogeneous tenton-like catalysts.
Yes.
Academician Agabekov.
Yes.
Please.
Yes.
Please.
Yes.
Вот, посмотрим, что в принтере. Можно начинать.
Так, а я же не вижу выразить. А меня-то не слышно.
Нет, вас слышно.
Слышно, да?
Да, пожалуйста.
I'm sorry. First of all, I would like to say some words about our celebration for the Dr. Georgi Duka, Professor Georgi Duka. I would like to say from the collaborators of our Institute of Chemistry of New Materials, Academy of Science, Belarus, and from Minister of Education, our country, Andrei Ivanets. Yes, he is our so-after. And from me to congratulate dear Georgi Grigorievich on your anniversary and wishing you a wonderful day and at the most amazing things in your future years of your life. Also, I also wish you and your family many happy years. You see, it's amazing things in your life this day. And we know you as a very honest man, very honest, well-known in the world scientist. You see, if you remember, Professor, we met the first time, it was in the Chemical Physics Institute in Moscow. It was in 1985 and 1986. And from that time, we have a good relations with you. We know you as a prominent scientist whose works are widely known in the world. You are the laureate of Moldova State Prizes. You in the field of science and technology. You awarded the Medal of the National Commission of UNESCO, as well as many other important awards. Dear Professor, you have also received honorary titles, Man of the Science in 1999. You are Fellow of the American Chemical Society, honorary members of the Academy of Science of Romania, member of the European Academy of Science and Arts. Dear Professor, my dear friend, I could say these words because I know you as a very, very good friend. Your many years of work is an example to follow for young scientists, and example of dedication and solving scientific and practical problems. We are proud that you are of our friend and you are deservedly an honorary doctor of our institute. You see, in if you remember, the first time we visit the Chisinau, we visit the Academy of Science. It was, just a minute, don't work, what?
Să spuneți că tot se înscrie, noi să-i transmitem acknowledgements.
The academician Agabekov, thank you very much for your warm
Just a
words
minute,
and
just a
kind
minute.
wishes.
What happened?
We record.
Excuse me,
All
yes,
presentation and, is
it's
recorded
only-
and presented online.
Yes, I presented it my report. You see, it's visited of Professor Duca of our
Yes,
institute.
yes, we see.
Yes, he is a honest member as the president of Chinese Academy of Science, the president of Kazakhstan Academy of Science, the president of Vietnam Academy of Science, and he was the president of Moldova Academy of Science. Now, I would like to say some words about our control synthesis and properties of mesoporic ferrum and nitrogen and carbon heterogeneous phantom-like catalysis. You see, yesterday I heard he's a very strong, very interesting report of Professor Duca about the phantoms process. And I would like to say that in our institute and in the Institute of Inorganic Chemistry, we also have deals with phantoms problems and with the synthesis and new catalysis for the producing of this and develop of this area of these fields of the scientists. Then the next, the purpose of this work is to obtain heterogeneous phantom catalysis based on magnesium, ferrite magnesium, and the carbon-nitrogen composites, as well as to establish the effect of the synthesis on their crystal structure, phase, and chemical composition, morphology, and properties. We synthesize three samples of composites by the three following methods. One of them is the synthesis of magnesium ferrites by the modified Zolger method and its subsequent mixing with melt and heat treatment of the mixture. The second one, it was the synthesis of carbon nitrate and its subsequent introduction into the glycine nitrate mixture and combustion initiation and heat treatment at 300 centigrades. And the third, the mixing of melamine and glycine nitrate mixture with the subsequent standard operation of the process obtaining magnesium ferrite samples. The calculated mass ratio of magnesium ferrite and nitrogen nitrate, carbon nitrate in all composites was equal 1:1. The catalytic activity of the composites was evaluated using model solution of methylene blue. As a comparative control experiment, the degradation of methylene blue in the presence of the hydrogen peroxide without adding a catalyst was studied. The catalytic experiment was carried out using a diode number 350, 370 nanometers and UV lamp with diode 200 and 280 nanometers as a source of visible and UV radiation respectively. I would like to present you some of the experiments, such as the first experiment. It was XRD data, and you can see that according to the XRD data, intensive diffraction peaks individual crystalline characteristics of magnesium ferrite oxygen with spinel lattice type of is this one. It's for the magnesium ferrite. Each one for the it's a core. I would like to say you that this one is at the core. This one it is they show you. I see it one is a shell, and you can see that of kind of this compound characterized that on the that it is the structure of these composites when we have a core and we have the shell is the same, which we proved it by the another method. Some of them it's by IEI spectra, ICAS spectra of all compounds. Most intensive absorption bands appear region at 19, as you can see, 1,650 and 1,300 centimeters, and attribute for the carbon-nitrogen bond visible characteristic of the conjugated structure of heptazone, and also in the region of 880 10 belong to triazine and indicates predominant formation of melamine condensation. ER spectroscopy data are in agreement with the result, as I say you previously, if X radiation and confirm the predominant formation of the nitrate carbon with a heptazine structure, with a cubic spinel structure, all composite samples. Another some images of the surface of composites, such well these composites which we synthesize, the surface morphology of the magnesium, ferrite magnesium as a ferrite magnesium as a core, and nitrate, carbon nitrate as a shell composite is represented by large agglomerates. You can see it from the 50 to 100 micrometers. It's this one, and the opposite when the core it is with the core it is nitrogen, carbon nitrogen, and magnesium ferrite samples has a morphology close to the magnesium ferrite nanoparticles, which indicates the formation of ferrite on the carbon nitrate surface. It you can see on this one picture. And on the surface of the magnesium ferrite and G samples, it's a mix for the carbon nitrogen samples, plate-like particles with a lateral size of 10-20 micrometers identified. They are covered with the particles of submicron size. And I say you about the kinetics investigation of this catalytic influence of these samples on the process. Line form is the first order kinetics model of methylene. You can see this one, and samples under various conditions of the catalytic experiment. It was the induct condition, is the A, this one for the induct condition. This visible radiation, it in this condition, And UV radiation, it is this part. And the next, I would like to say, as you can see, the highest values of constant of this process equal to 0.109 and 0.153 minus -1 we obtained using UV radiation for samples. As you can see, this one, you can see radiation of nitrogen, carbon nitrogen, ferrite magnesium, and as a core, and carbon nitrogen as a shell. And you can see under the same condition, and these samples catalyzed showed a decrease in activity in approximately 2 times. The values of constant did not exceed more than 0.069 minus. When irradiated with visible light, all samples has low values of apparent rate constant, as you can see. And you can, under the dark condition, is the dark conditions you can see, is the visible radiation and the UV radiation. As the most activity, it's in the conditions under the UV radiation, is the number of 0.153. Among the visible radiation, it's only 0.002. And I would like to say that this, our conclusion, I would like to say that the Zorgen method in combination with the thermochemical condensation were used in synthesized heterogeneous phantom catalysis based on the magnesium ferrum oxide and carbon nitrogen composites. It will be found that all composites were characterized by the formation of carbon nitrate with the conjugating aromatic structure of S-geptazine. The efficiency of catalytics and destruction of methylene blue decreases in the following range. It's the first, the highest it's under the UV radiation, then dark condition, and then visible radiation. When using UV radiation for magnesium, magnesium as a core and carbon nitrate as a shell, with core and with core, when with the carbon nitrate as a core and shell is a magnesium ferrum magnesium ferrite magnesium structure, the highest apparent rate constant is approximately 0.1, approximately 115 minus were achieved. That's all. Thank you ever so much for your attention. Thank you so much for your attention, and excuse me that it was not so well as how I can say so well my English. So well my English. Thank you so much for your attention.
Thank you very much, Academician Agabekov. Please, questions. Можно вам задать на русском вопрос?
Конечно, это даже будет лучше, потому что я пока переведу на английский, это будет сложнее.
Скажите, пожалуйста, господин Агабеков, Вы не сравнивали с гомогенным катализом окисления метиленового синего?
Да, это делалось. И это делалось, по-моему, мы делали это предварительно, и оказалось, что, во-первых, это значительно дешевле, то, что мы делаем, то, что мы получаем. И это значительно, ну, практически может быть, ну, использовано более вероятно на практике. Я вам сейчас скажу, где это статья моя, сейчас мы найдем эту статью. С самого начала, где-то эта статья. Мы пробовали это делать, и я вот, какой мы сделали отсюда вывод, когда мы это брали. Мы сделали отсюда, что вот эти гетерогенные фентоновские процессы, они на продуцирование реакционно-активных радикалов. Ну, это известные вещи, это очень хорошо рассказал вчера профессор Дука, он в своем докладе очень хорошо это рассказывал. Вот и когда мы сравнивали это непосредственно, гетерогенные железосодержащие катализаторы и композиты, они позволяют что? Они прежде всего позволяют снизить расход реагентов и обеспечивают эффективность каталитического процесса в широком интервале pH, без образования кислотных стоков. Вот в этом, это была, так сказать, ну, основная наша предпосылка для того, чтобы заняться вот синтезом вот таких катализаторов. И что можно заметить, что действительно самый вот это интересный каталитический эффект, когда не просто смесь, вы берете вот магний, феррит магния, так сказать, оксиды феррита магния, и смесь берете карбонанитрида, просто смесь. Но когда вы делаете это в виде ядра и в виде оболочки, то вся на поверхности, которая получается, там на поверхности образуется сразу же железо трехвалентное. И оно быстро, так сказать, разрасходуется, и быстро процесс уменьшается. В данном случае, когда ядро сидит уже внизу, то есть железо внизу, оно в меньшей степени подвергается окислению. И больше образуется вот этих гидроксильных радикалов, как мы предполагаем.
А
вот
скажите, а интервал pH какой у вас?
Что вы сказали?
Интервал pH.
pH, по-моему, там был от... Точно, я сейчас скажу точно. Где-то я просто сейчас этого не помню. Но я сейчас скажу точно, какое брали pH. Сейчас я прошу прощения. Я не помню точно.
Наверное,
вот,
ближе к
pH
нейтральным.
было...
Ближе к нейтральным.
Ближе к нейтральным, правильно, было около 8. Вот pH около 8 вот в этом интервале. 7, 8, даже чуть-чуть выше немного.
Спасибо. Thank you.
Около 8.
Other questions?
Можно спросить, Владимир, а вы использовали вот этот синтезированный катализатор в виде микрочастиц и облучали?
Да.
Таким образом облучали? Просто перемешивание под действием ультрафиолетового света? Или это какая-то у вас...
Да, перемешивали под действием ультрафиолетового света. И самое главное, что можно было их тогда... у нас идея была какая, чтобы это понятно, что ультрафиолет используют в таких практических целях. И мы просто эту смесь, когда пропускали, ее просто облучали сразу же под действием лампы. Это и мы делали эти.
На ваш взгляд, это имеет промышленное применение, в больших объемах?
Вы задали такой же вопрос, который мы все время с Иванцовым обсуждаем. Если сделать, в принципе, для катализаторов или для процессов каких-то, таких сейчас, как сейчас модно, для малотоннажных процессов производства, то можно сделать такой проточный реактор под ним. В принципе, УФ-лампу, УФ-радиейшн найти это несложно. И, в принципе, может проточную систему с определенными скоростями передвижения, можно это сделать. Хотя, пока это вы же видите лабораторные испытания.
Хорошо,
Но
спасибо.
это перспективно, на наш взгляд, тоже это перспективно.
Спасибо.
Самое главное, что я был очень доволен, что вот вчерашний, так сказать, доклад Георгия Дука, я вижу, что его нет, но прошу передать ему, может он слышит, может не слышит, наши большие поздравления. Я не знаю, получил ли он наш адрес, мы ему посылали адрес.
Да, он в курсе, он все следит, все видит.
Но все видит, а тем более.
Онлайн, да.
Георгий, мы вас ждем. И еще раз я хочу пожелать ему, я уже по-русски скажу, пожелать ему самое главное хорошего здоровья.
Спасибо.
Самого главного хорошего здоровья. И надеюсь, что в ближайшем будущем все же мы встретимся. И наша дружба будет продолжена. Все наши сотрудники с огромным удовольствием вспоминают его визит к нам, его интерес к нашим работам. И, естественно, наши, так сказать, ребята новоиспеченные, как и Андрей Иванец, как и Рогачев, они благодарны ему за его поддержку, которую он оказывал им во время наших
Questions? Thank you very much, Academician Agabekov. Thank you.
Thank you. Thank you.
Next presentation, Professor Constantin Bulmaga, Institute of Ecology and Geography, Moldova, Evaluation of Impact of the Biological Waste Treatment Plant in Florești on the Ote of the Reut River. Please.
Acesta? Nu? Nu. Nu coși. Nu coși un moment. Florești, nu? Da.
Академик Агабеков, вы нас слышите еще?
Nu coși trec. Я как уж.
Please, Professor Constantin Bulmaga.
Thank you. Microfonul aici, vorbiți în direcția asta. În direcția asta, I represented the Laboratory of Eco-Urbanistic from Institute of Ecology and Geography. In last 20 years, we carry out a big volume of research on the impact of eco-urbanistics ecosystems on the environment. We carry out the research of Chisinau impact on the environment, or impact ecosystems on different different soil components of environment and other ecosystems urban. Now we carry out the results from research of impact of from florist treatment plant. This station is placed in the north place of our republic, and we carry out the research in the water which we obtain from water treatment plant. We obtain the next results. This is the dynamic of limits of sustainable substances. This we have a big pollution which we obtained in the 2018 years and 2020. The next results, we have a dynamic of contained oxygen demand. The main impact we obtained in 2018 years. Next results we have on dynamic of biological oxygen demand. The main impact we obtain in the 2018 years. The next research, we have a dynamic of chlorine ions on the environmental. The most of impact is in 2018 years and in 2019 years. We have a results of big pollution with ammonium. This impact we obtain in 2018 years. And last results, we have a big impact impact of nitrate ion on the environmental. And in conclusion, we have established that the main impact is from substances, suspended substances. It is consists, the main is 1 to 70 times. For oxygen demand, the main impact is 2.36 to 4.70 times. For biological demand, the main impact is consists 2.40. The impact from ammonium is 2.13 to from 2.13 to 1064 times. The results is show us that the wall of treatment plant, water treatment plant, have a big negative impact on the superficial water. This is we can explain this with the lower grade of water purification, residual water purification. Thank you for that.
Thank you very much, Professor Burmaga. Please, questions?
Я задам потом.
Да, давайте сейчас задавайте.
Я могу по-русски, мне кажется.
Да, давайте по-русски.
Я заметил, что самое такое сильное влияние в плане концентрации состоит в том, что высокие концентрации в холодное время года, так?
Да.
Вот. И как вы, я понимаю, что, скажем, биологическое потребление кислорода в эти периоды просто в природе более низкое из-за низкой температуры. А как объяснить, там, скажем, высокие концентрации аммония в весеннее время?
Это, видимо, можно объяснить, во-первых, степень очистки от чего зависит. Зависит от качества ила, который используется, потому что это биологическая очистка. Это зависит от чего? От качества ила, который используется, потому что это микроорганизмы. Но скорость вот очистки от чего зависит? От температуры и, конечно, от качества ила. И, видимо, когда холодно, значит, это я имею в виду активность, вот это микробиологическая, это низкая очень при холоде. А вот весенний, вот когда бывает, это, видимо, можно объяснить тем, что может быть это степень, я имею в виду степень загрязнения вод, потому что это повторяется в одно и то же время, значит, это была очень высокая степень загрязнения сточных вод, потому что они, значит, вот эти станции, они имеют предел, я имею в виду, вот как, например, в Кишиневе. Допустим, она может очищать большой объем воды, но все зависит от степени загрязнения вод и от природы вот этих загрязнителей. Раньше, вот до 90-х годов, мы проводили большой объем исследований, значит, они очищали 340 тысяч кубических метров за 24 часа. Сейчас, в последние годы, потом было 230, а сейчас в последние годы, значит, только порядка 130 тысяч кубических метров за 24 часа. То есть объем воды уменьшился, но основная масса загрязнителей, то она осталась. Это первое. Второе, значит, степень, я имею в виду, очистки зависит еще от того, я имею в виду, какие там загрязнители сбрасываются на сточные воды. Вот недавно, вот в прошлом или позапрошлом году, значит, я сделал, у нас было станции, значит, очистных сооружений, я сделал экологическую экспертизу, значит, и там вот эти, которые сбрасывают туда загрязнители. Так вот эти превышения по химическому потреблению кислорода, по биологическому потреблению кислорода, по этим веществ, это иногда превышает 50, 60 и 70 раз. То есть, в конце концов, мы можем сказать, что она, очистительная, я имею в виду станция, сооружения, они могут обеспечить, я имею в виду, нужный уровень очистки, но для этого мы не должны превышать, во-первых, степень загрязнения вот этих сточных вод, и, во-вторых, значит, то, что мы туда сбрасываем, потому что, допустим, вот здесь в Кишиневе они туда сбрасывают из винных заводов, из пивзаводов, далее вот есть станция молочная, значит, без очистки они туда сбрасывают. И, конечно, это, наша вот эта Кишиневская, она не может обеспечивать, значит, качественную очистку вот этих загрязнений. Вот в чем дело. Станция, она рассчитана на какой-то объем загрязнений, удалений. Вот, и, кстати, вот когда производится, значит, очистка, где-то порядка мы проводили широкий, значит, объем этих исследований, значит, порядка 50% загрязнений удаляется, значит, оттуда ввели. Но 50% загрязнений все-таки они остаются, и сбрасывается с очищенными уже вот сточными водами. Так вот эти очищенные уже сточные воды после очистительных сооружений, значит, они приводят к большому загрязнению поверхностных вод. И это у нас было доказано. Вот с эти станции Кишиневской, Сергеевской, далее, я имею в виду, вот в Бельцах, и вот это последнее Флорешское. Значит, и мы убедились уже, что все очистительные сооружения, значит, они являются как бы источником загрязнения поверхностных вод. И напрашивается вопрос, значит, что делать, чтобы исключить это. Дело в том, что, значит, или надо добавлять новую, я имею в виду, метод, допустим, обратный осмос, как есть некоторые станции, значит, которые улучшают эту очистку, или, я имею в виду, разбавлять каким-то образом, значит, или модернизирование, да, или новый этап добавлять, потому что они, как говорится, это идет хорошая очистка, но не тот уровень, который нам нужен. Например, для вот этой Кишиневской очистительной сооружения, значит, мы рассчитали, если мы без очистки выбросили бы полностью, значит, в бык вот эти сточные воды, так у нас была бы катастрофа. В смысле, полностью бы мы вывели из строя все. Еще вопросы?
Other questions? Next presentation, Larisa Mocanu, Moldova State University, Moldova, removal cephalexin from aqueous solution by photodegradation. Please.
Thanks, Mrs. Gonza. I will share ekran. But please confirm if you see my screen.
Da, мы видим.
Да, screen meu.
Screen-ul nu se vede pe mine.
Acum. Now?
Da, yes, da, yes. Please.
1 second. Okay. Water is a natural resource indispensable to any ecosystem. Its quality and recent decades, it's one of the biggest concerns of scientists in the field of environment. According to WHO and UNICEF, 100 million people don't have access to safe drinking water. Of each, 185 million use surface water to meet their daily needs. The risk associated with pollution with compound derived from pharmaceutical industry is highly topical. One of the most widely used antibiotic is cephalexin. It has used in veterinary and human medicine. Studies show that only 10% of the cephalexin consumed is metabolized by the body. Due to their high solubility and complex structure, beta-lactam antibiotics are quite chemical stable and have developed resistance to natural process of chemical, photochemical, and biochemical degradation, leading to their long-term presence in environment. As a result, small amounts of pharmaceutical compounds are detected in surface groundwater in drinking water. The main aim of this research is to study the degradation of cephalexin from aqueous solution by applying homogeneous and heterogeneous oxidation. The study object is, of course, cephalexin. which is a beta-lactam antibiotic. Removal of pharmaceutical compounds from aqueous environment is one of the most significant priorities in the field of wastewater treatment. Having a complex composition, these pollutants are difficult to remove by conventional or biological methods, and the application of photochemical methods it's one of the effective alternatives. From this point of view, various advanced oxidation process have shown the ability to remove antibiotic from aqueous solution. According to the most published studies, due to high degradability, non-toxicity, universal viability, and acceptability, IOPS has become a promising option for efficiently handling persistent pharmaceutical chemical. The effect of varying experimental conditions such as pH value, initial concentration of oxidant, catalyst, and substrate reaction time of the removal of cephalexin has, of course, examined. According to figure 1, the removal of cephalexin depends on the pH value, which direct influence the structure of antibiotic, the red constant as well production of hydroxyl radical. Different species of iron ions are formed in reaction system, which are main components responsible for decomposition of hydrogen peroxide. And the generation of hydroxyl radical. The effect of initial pH value of cephalexin remove rate and photophantom system was examined under different pH level ranging from 2 to 11. This range was made in accordance of pK value of cephalexin. Views in first minute. 50% of cephalexin has degraded, after which there is a decrease of over 20% for 30 minutes. For this study, 88% of degradation has obtained in a strongly acidic condition, and respectively decreased non-essentially with increasing pH value. The decreased cephalexin concentration is due, on the one hand, to the hydrolysis and dimerization reaction with the formation of intermediate, and on the other hand, it depends on the amount of hydroxyl radicals. The effect of the photocatalytic reaction by titanium dioxide was extensively studied due to the fact that photocatalytic water is highly depends on the pH value as it affects the charge of the catalyzed particles, size of aggregate, the position of conductance on valence bands. Furthermore, the surface of dioxide titan can be protonate or deprotonate under acidic or alkaline condition. However, the surface of the titanium dioxide is positively charged under acidic condition and negatively charged in alkaline condition. In order to study the effect of pH heterogeneous degradation of cephalexin, a series of experimental research have performed in pH range from 2.5 to 9.7. As a result, it was found that cephalexin degradation in the presence of hydrogen peroxide catalyzed by titanium dioxide upon irradiation of UV rays in the pH range of 3.54. Degradation has reached up to 50% for 10 minutes. More than which increasing reaction time or pH value, the degradation rate has decreased. which has indicated that the catalyzing is activated under this working condition. Cefalexin, according to figure 2, cefalexin show maximum absorbance at 260 nanometers, and it can absorb light below 300 nanometer. However, insignificant degradation we expect with 365 nanometers irradiation and presumably the degradation was due to antibiotic hydrolysis. The hydrolysis reaction would proceed through the attack of the nucleophile water to the beta-lactam ring, followed by ringing open. According to figure 2, we can see that homogeneous oxidation can take place at 254 nanometers and heterogeneous oxidation 200 at 365 nanometers. And continue. I will talk about photophantom degradation because it has highly efficiency. According to figure 3, the concentration of hydrogen peroxide is another parameter that influences the photophantom process. The optimum concentration of hydrogen depends on the concentration of substrate. Theoretically, 4.38 milligram of hydrogen peroxide is required for complete mineralization of milligram of cefalexin. Despite of an excess of hydrogen peroxide, for the complete removal of cefalexin from wastewater is required. It's according figure 3a, it's observed that the removal cefalexin photooxidation process depends on oxidant concentration, which is also confirmed by the red constant. Based on the results, it's found that 3.4 milligram per liter peroxide hydrogen is required to oxidize 50 milligram per liter of cefalexin. Additional concentration of hydrogen peroxide inhibit the formation of hydroxyl radical and lead to the generation of hydroperoxyl radical, which has a lower oxidation potential compared to hydroxyl radical. However, we can conclude that high concentration of hydrogen peroxide acts as an inhibitor of hydroxyl radical formation. As a result, reduce the efficiency of process. According to figure 4, in order to determine optimum catalyzed concentration, the concentration of hydrogen peroxide was kept constant, and the concentration of ions was varied in a range from 0.56 to 28 milligram per liter, taking into that the permissible concentration limit of iron ions is 10 milligram per liter. It's observed that as the concentration of iron ions increase, the degradation performance and decrease from 73% for the concentration of 0.56 milligram per liter to 46% for 28 milligram per liter iron ions after 60 minutes of reaction. This efficiency is also confirmed by the rate constant. views, it's found that the degradation of cephalexin is practically proportional to the formation of hydroxyl radical. As the catalyzed concentration increase, the excess of iron ions react with the hydroxyl radical and forever reduce the process efficiency. According to figure 5, the rate of catalytic degradation of certain pollutants depends on the nature concentration of compounds in water matrix. In order to optimize the concentration of cephalexin, the removal efficiency effect on the degree of mineralization in the concentration range from 50 to 200 milligram was investigated. According to the figure 5a, the efficiency of cephalexin degradation decrease as the cephalexin concentration increase up to 200 milligram per liters antibiotic. Moreover, a high degradation was achieved at 2 hours of reaction at a concentration of 50 milligram per liters of cephalexin. In addition, the rate constant, like this decrease with increasing cephalexin concentration. Hydroxyl radical can easily remove a high concentration of contaminants, but as a concentration of cephalexin increases, the amount of hydroxyl ion produced isn't sufficient for the complete elimination of antibiotic. High concentration of cephalexin in water saturate the titanium the titanium dioxide surface and hence reduce the photonic efficiency and the activation of the photocatalyzed. Forever, the photocatalytic degradation of aromatics is highly dependent on the substituent group. The organic substrate of electron withdrawing nature, benzoic acid nitrobenzene strongly adhere to be photocatalyzed and forever are more susceptible to direct oxidation compared with electron donating group. In conclusion, we can see that homogeneous oxidation it's okay for cephalexin with reagent photophantom at 254 nanometers, and of course, if degradation or oxidation mineralization increase with increasing cephalexin concentration and decreasing when is applied heterogeneous oxidation at 365 nanometers. And this table is a comparative results about all the chemical methods, AOPS chemical methods, and we can see what cephalexin in presence of photophantom reagent has a red constant with 0.02 second, and degradation is 55%, and oxidation mineralization is 82%. Heterogeneous oxidation is about cefalexin in presence of titanium dioxide and zirconium, and a big degradation is 47%, and oxidation mineralization 82% with a rate constant about 0.009 second minus 1. In conclusion, according to the experimental results, the efficiency of photophantom and photocatalytic process depends on several variables. It might be concluding that the effect of each independent variable depends on the value of the other due the existence of simultaneous interaction. Use any of the variable could positively or negatively affect both the degradation and mineralization rate of cephalexin. The highest cephalexin removal rate was achieved at acidic condition, pH equal 2.5 for homogeneous oxidation and pH equal 3.8 for heterogeneous oxidation. The removal process of cephalexin could be described by the pseudo first order kinetics. Optimal reactant concentration have been established, such as 50% milligram of cephalexin is required to oxidize 3.4 milligram per liter of hydrogen peroxide and 5.6 milligram of iron ions. It was concluded that photocatalytic process can be a potential method for removal cephalexin in optimal condition at real concentration. Thank you for attention.
Thank you very much. Please, questions? No. Thank you.
The next speaker is Aneta Svolskova, Krakovskaya, Russia. Phytoremediation of laden wastewater using a constructed wetland treatment system. Please. Yeah. Please.
Another option is you can send to my email your presentation and I will change the slides. Oh, of course. Afterwards, yes. And now presentation, you? Yes. Okay, okay. Our presenters, if you don't mind, we will exchange the places. So instead of Mrs. Muzabar, I would like to invite Mr. Rustam Sherhanov from the Lokmera Ltd company, Moldova, who will talk about the identification of emerging contaminants in air, water, and soil. So I will give you the floor now. I think.
Next is Dr. Camelia Marcantonio. Environmental risk assessment associated to organic micropollutants on the final effluents of urban wastewater treatment plants. Please.
Good morning. Yes. Can you hear me? Okay.
Yes,
okay.
Okay, one moment. Okay. Good morning, everybody. I'm from La Sapienza, University of Rome, and this work is in collaboration with the water service of the main city of the city of Rome. First of all, I would like to introduce what we mean with organic micropollutants. or contaminants of emerging concern. These are contaminants present in the environment at very low concentrations. Several chemicals belongs to these definitions, such as pharmaceutical, endocrine disrupting compound, but also industrial compound, antibiotics, and so on. And one of the main sources of release of these compounds in the environment are the wastewater treatment plants, because they are not specifically designed to remove this type of contamination. So as a consequence, at the moment, the knowledge about the fate, the presence, but also the removal of these compounds in the wastewater treatment plants, but also in the environment, is still not completed. And as a consequence, there is a continuous development of the legislation about this type of contamination. So, for example, in terms of European legislation, the process started in 2000. But the last update are related to last year, in 2020, with the new regulation for drinking water and the minimum new regulation for the minimum requirement of for the water reuse in agriculture. In this scientific field, we are studying a list of compounds belonging to the class of pharmaceuticals, specifically carbamazepine, ketoprofen, warfarin, but also antibiotics, caffeine, and illicit drugs and their metabolites. And I'm going to present you two studies, two monitoring activities, actually. The first one related to two wastewater treatment plants in the, close to Rome, where we monitor the water treatment line of these two plants with several objectives. The main objective that I'm going to present to you today is about the risk assessment. Particularly in the first plant, the treated water is reused for a non-potable application. And we assess the health risk, so the human health risk related to this type of reuse. In the second plant, the effluent is discharged into a river, and here we focus on the environmental risk assessment, performing also a monitoring activity on the river, where the effluent is discharged, so to collecting sample upstream and downstream compared to the point where the treated effluent is entering to the river. In the second investigation, we focus on 8 wastewater treatment plants again in the same area, so in Lazio region, in the central part of Italy. We select these plants because they are quite different in terms of treatment layout, but also treatment capacity. One of the main objectives was to evaluate the performance of this treatment and the effect of the different characteristics on the organic micropollutant removal, but also we improved the environmental risk assessment, evaluating the risk for individual substances and the risk for a mixture of substances, but also considering the different disposal of the different final disposal of the treated effluents. For the first investigation, these are the results of related to the first plant, so where we focus on the health risk assessment. Here we apply a procedure based on scientific literature, where the risk quotient is defined as the ratio between the acceptable daily intake, which is a specific value for each substance, and the exposure. For exposure, we consider different scenarios and different receptors. Specifically, the reuse of this water is related to the irrigation of urban parks and fountain feeding, ornamental fountain feeding. So we choose as exposed receptor the maintenance workers as an example, and children, considering two different types of exposure, two different scenarios of exposure. and also dermal contact and incidental ingestion for the type of a connection between the exposed receptor and the contaminated water or the reused water. So we take into account different characteristics of the receptor and also the substance that we evaluate. And on the right part of the slide, in the graph, we are reported the results. We consider also two contamination scenarios, one considering the median concentration measured in the effluent of the plants and the 95 percentile of the concentration. So as we can see, the risk was always considered acceptable because below 1, which is the threshold value. And the highest risk is related to carbamazepine, which is an anticonvulsant agent, and methamphetamine, which is an illicit drug. So even if this is not a concern condition for the target receptors, this for us was quite interesting to at least evaluate the possible risk in terms of contaminants. For the second plant, where the effluent is discharged into a river, we apply a procedure defined by the European Medicine Agency in a guideline for the evaluation of pharmaceuticals, where the risk, the environmental risk is defined as the measured environmental concentration divided by the predicted no-effect concentration. So the last value, the latter value, is based on a standard bioassay test. So we collect this value from literature, for scientific literature, and the measured value is are related to our monitoring activities. So as we can see from on the right part of the slide, the graph show that in this case, again, the risk was always acceptable because the threshold value is again 1. And again, carbamazepine represents the most concerned compound among our list of compounds. And interestingly, we also find out that some compounds represent already not a risk, but there is a source of contamination in our river related to some compound which is independent from the effluent of the wastewater treatment plants. This is a preliminary study for us about the actual impact on the river of this related to the quality of the river in terms of contaminants of emerging concern. So these are preliminary results and quite interesting for us. And that's it. For the second investigation, where we focus on 8 wastewater treatment plants, in this case, we take into account also the differences in terms of final disposal of the effluent in the different plants. Particularly among the 8 plants, 3 are allowed to discharge the effluent directly into the soil. So this is a definition from the Italian legislation, but actually means that the flow rate of the receiving water body is much lower than the flow rate of the wastewater treatment plants. Then we have other 2 plants that discharge in one river and 3 other plants that discharge the effluent in another river. Here again, we apply the European Medicine Agency procedure, and we take into account with a specific dilution factor the difference, the actual dilution that the concentration undergoes when the effluent is discharged into the receiving water bodies. So what we can see from the results in the graph is that first, in these cases, we have an actual risk for the environment for carbamazepine. Again, carbamazepine is a very persistent compound and as well known as a concern compound for the aquatic environment. And another interesting result is that the highest value of the risk, and actually the no acceptable value of the risk, were found out when the effluent is discharged into the soil. So where the dilution factor was equal to, so where no dilution was considered. For the mixture of substances, we have to highlight that there is no threshold value for acceptable or no acceptable risk for this type of assessment. But for us was quite interesting because we verify that we select, so we make the evaluation considering 3 different classes of compounds and the overall risk. And we highlight and we verify that the risk, the overall risk was mainly due to the class of other pharmaceutical, we call it, where carbamazepine and caffeine are included. Illicit drugs doesn't seem to be a very concerned class of contaminants among this list. Antibiotics provide just a very contribute to the overall risk at a very low extent compared to the other pharmaceuticals. So in conclusion, what we find out with this investigation is that for the reuse of water in not non-potable application, there is the risk was considered always acceptable, but this is related to this particular situation and conditions. For the environmental risk assessment, the compound of major concern is carbamazepine, and the dilution of the final effluent is a key parameter for that is very important to take into account, even because in the European guidelines it's suggested to take a fixed dilution factor, which is equal to 10. And so from this investigation, we prove that this is quite important to calculate and to verify which is the case-specific dilution factor. And we also verify that the major contribution to the overall risk of this type of this list of compounds is related to the class of pharmaceuticals. At the moment, we are still working on this project, but we are moving now on the study and the experimental activity related to advanced treatment technology to improve the removal of the compound that were depicted are major concern based on the environmental risk assessment. I would like to take the opportunity to invite you to a special issues of the journal Water, where my supervisor, Professor Maria Rosaria Boni, is a guest editor. And the special issues is about the biological wastewater treatment towards a sustainable circular economy. And thank you for your attention.
Thank you very much. Any questions, please? Have any question? No, thank you very much.
Thank you.
The next speaker is academician Professor Asaf Ajiyev with report Actual Problems of Environment and Pollution. Please.
Okay, do you hear me?
Yes,
yes.
Yeah, okay. And do you see my slides?
Yes.
Not yet, no.
Okay. Okay. Dear Chairman, dear colleagues, first of all, I would like to address you on behalf of Parliamentary Assembly of the Black Sea Economic Cooperation. At the same time, I would like to express my deep gratitude to academician George Duca for invitation to have presentation in this very important gathering, I would say very important scientific forum, and for his effort for preparation this conference. I will tell you about the modern problems of ecology in the Black Sea region. And first, I would like to inform you, no formula. I am a mathematician, but in presentation there is no formula. If somebody will be interested in statistical aspects of ecological problem, I have another presentation, but it is another story. Now I would like to present you general vision to this issue, to this problem from Black Sea region. First of all, I'd like to inform you about wider Black Sea region, which is a huge region, which is included Black Sea, of course, Caspian Sea, Mediterranean Sea, Aegean Sea, Marmara Sea, and other. This is a huge region, and the confirmation that is a very huge region can be that several not Black Sea countries like France, Germany, Austria, United States has special status in our organization. Why Black Sea region is important for the world today? First of all, the Black Sea region can be considered as, geographical position as a bridge between Europe and Asia. At the same time, it can be considered as the intersection of the world transportation roads like Silk Way from east to west, and also so-called Viking Way from north to south. But at the same time, the region is very rich in energy resources, where energy, oil and gas, are delivered from Black Sea and Caspian Sea to the world market. And recently, it has gone maybe 15 years, even more, it was built, the main pipeline for oil delivering from Caspian Sea to world market. It is called Baku-Tbilisi-Ceyhan. You can see here. Another project, the region is famous that a lot of huge projects are implemented here. For instance, Baku-Tbilisi Cars Railway project. I am sorry. Yeah.
The academician, we don't see your presentation.
You don't see, but you didn't tell me. Wow. But how? You do not see?
Share your presentation.
This is it, but I asked, do you see my slides? You told me yes.
No.
No, just a moment. But you were keeping silence. And so, but just a moment.
Very interesting report.
Just a moment. My assistant will help now. I don't know why. This is very strange. Really very strange. Do you see me now?
Yes, we see you.
Yes.
To whom?
Как делать? Так? Отсюда? А сейчас что?
Share надо нажать.
What do I share?
Share screen.
I share here. Wonder. Something happened. I don't know. No point. So I have to start from beginning, I guess. Yes. Just a moment, please. Share. But you do not see, right, my slide? Excuse me?
No.
What do you see in the screen?
We see just you. Just
me.
screen. Not your presentation.
Not my presentation. This is very... Вот здесь внизу. But I guess now you see, right? Do you see?
Just a moment. Yes, now, yes. It's okay.
Okay,
Yes,
thank you very much. So I have to start from beginning, right? As I understand. Do you see?
Yes,
Do you see slide?
Yes,
Yes,
now
we
it's
see.
here.
Okay, let's start. I will be very fast a little bit. I'd like to give information about ecological problem in the Black Sea region. This is there is international terminology, wider Black Sea region, which includes a lot of seas: Mediterranean, Aegean, Caspian Sea, Ionic Sea, Marmara Sea, and so a lot of country who has no coast on the Black Sea, like France, Germany, United States, Austria. They have different various status in our organization. It means that this region is very attractable from world point of view. But why it is important? First of all, the Black Sea region can be considered as a bridge between Europe and Asia. At the same time, it's intersection of the world transportation roads, for instance, Silk Way from east to west, and so-called Viking Way from north to south. And a lot of huge projects are implemented in this region, like because region is very rich in energy resources, gas and oil, and gas and oil from Black Sea and Caspian Sea are delivered to the world market. And some transportation projects have been implemented, like Baku-Tbilisi-Kars as a railway, which decrease the distance between Europe and Asia, not distance, I mean time for delivering goods, right? And recently it was built the gas pipeline, Trans-Adriatic pipeline, TANAP, and its continuation, its TAP, where gas from Caspian Sea is delivered to Europe, Italy, Bulgaria, Greece, Albania, and other countries. But the most important value of the Black Sea is not geographical position. It is not that the region is rich in energy resources. The most important value of the Black Sea, it is a people who lives here. It is different nations with different languages, different traditions, and different religions. And so our obligation is to bring here peace and prosperity. But for prosperity today, it is very important ecological problem. Why ecological problem so important for us right today? Because environmental issues concerns and prioritize interest, and the World Banking plays attention to the ecology problem. But why today? Because there's, in my view, 4 reasons. First, is the usage of IT and also scientific achievements in the world for ecological issues. The second, the world interest to green economy, which is strongly related with ecological problems. Third, United Nations Sustainable Development Goals, where the green economy is underlined. And the last one, the world interest to renewable energy issues, because it is very important today for the world. And so, but these 4 reasons confirm that the world pays serious interest to ecological problems. Because the new ecologists can save our planet. As technology becomes ever more advanced, its adverse effect on our planet are lessened, while its potential for positive impact increases. There's several aspects. Here's the 8 ways technologies currently helping the environment. First, we use less energy to do everything. Other clean energy system is more effective. Food production is becoming more eco-friendly. Cities are becoming less polluted, and people are becoming more aware of our effect on the planet. This is what new technology gives to the world. And also other, let me change it. Just a moment, please, because I'd like, okay. That's bad. So, green economy. As I mentioned in United Nations Sustainable Development Goals, it is underlined because green economy needs renewable energy. It is solar energy, it is wind energy, as you know. And also, it is important water management, because today in the world, every day 2 billion people has problem with water, and so the world has to think about this. Fact about the relation between sustainable green economy and of people health. It's also very important because, you know, but the people health depends on green economy, because we can stop, we can decrease using gas, oil, and other energy resources. At the same time, green economy allows to bring in our life more clean food and others, right? But here I just present you some ideas. For instance, the chronic hunger affect more than 850,000 people. 500 million suffer from obesity. Air pollution kills an estimated 7 million people every year. You can imagine that 7 million people have been killed. And every day I was told that water problems, there is a water problems. About solar energy and radiant energy emitted by the sun. It's also known as the solar power. What's happened? Oh, once again, it stopped. Okay. Okay. So solar energy needs, of course, usage of IT technology, all right? And depends, of course, it depends strongly on the climate. And so in the south, of course, it's more sunshine and the people, the countries can use solar energy. But fortunately or unfortunately, it needs very high development of the science. For instance, in Africa, the good climate condition for getting solar energy, but unfortunately, they do not have high level of scientific development. And so I think the developed world should help to other countries to use solar energy. Other advantage of solar energy. The solar panels give off no pollution. Solar energy produces electricity. It has the ability to harness electricity, very efficient in large areas of the globe. Solar panels can be installed on the top. It is affordable in the long run. And so we have to use this solar energy. This is just some examples. And of course, it's important wind energy, because the country like Denmark, for instance, they have high development of using wind energy because there is a lot of wind. For instance, the country where I am from also has a lot of wind per year, and we are trying also to use wind energy, but not so successful because we do not have high technology for this, but we are trying to share with other countries. Wind energy is a source of renewable energy. It does not contaminate. It is inaccessible and reduces the use of fossil fuels, which are the origin of greenhouse gases that cause global warming. For these reasons, producing electricity through wind energy, it is efficient use, contributes to sustainable development. Advantage of wind energy. It is renewable source of energy. Wind power systems and non-polluting, so it has no adverse influence on the environment. Wind energy systems avoid fuel combustion and transport, and last, cost-free renewable resources. This is example of using its renewable source of energy. Wind power systems are non-polluting, so it has no adverse influence on the environment, and cost-free renewable resources. And the country who has high achievement in using wind energy, as I mentioned here, Denmark, and also in Germany, Poland, and some European countries. And this is, yes, and the Parliamentary Assembly of, our organization of the Black Sea Economic Region pays particular attention to environmental issues. One of the most dramatic problems facing the Black Sea region today is the degradation and pollution of environment, and first and foremost of the Black Sea itself. One, its part, the Assembly advocating the environmental sustainability as a significant factor of the economic development of the countries in the region. PubSec is fully aware that global climate change poses a serious threat to the future of the planet and endangers socio-economic progress in the region and requires sustained and concerted high-level attention. The Assembly is committed to contribute to further the dialogue to address climate change under the existing international instrument and to work with all members of the international community for an enduring global solution to climate change with due regard to specific national and regional development priorities, objectives, and circumstances. And we have several activities as a PubSec in environmental protection. It's shown here. We prepared several reports and prepared several recommendations for parliaments, how parliament can use, and we share with them achievement of other parliaments, and we hope it will help for preparation legislation in the field of ecology. And this is, and thank you very much for your attention. And once again, very sorry for technical problems which we had here. Thank you. If you have any question, please, I'm ready to answer.
Thank you very much. Have you any question, please?
Can I ask or can I speak something?
Yes,
first of all, I want to thank dear Professor Academician and dear President of PubSec, this very important organization for Black Sea. I don't know. I think if PubSec will be intermediate through Russia and Ukraine, might be resolve solution. You can to find the solution to resolve this very, very big problem. This is a very not only military problem, not only political problem. The consequence of this conflict is very bad for environment, for infrastructure, for treatment of water, for increment of atmosphere or soil. It's very important. I think is your presentation is very important. Your position and this. I know, dear Asaf, you are very, very big diplomat. Very big.
Thank you. Thank you very much.
And I ask you if PubSec discuss the environment problem like consequence of this work.
Thank you very much, Academician Duka, for warm words about our organization. Of course, we are worrying about situation between Russia and Ukraine because both countries are members of our organizations, right? Because this war, I mean, as a result of this war, a lot of people have been killed from both sides. At the same time, it is a huge damage to the economy of the region, not for economy only two countries, but for region. And of course, you are absolutely right. I am absolutely agree with you, but it is damage to ecology, right? We are worrying about it, but we are economical organization, you know, PubSec, it's economical cooperation. Unfortunately, we do not discuss conflict, but of course, we will express our worry about situation. And about your last question about our interest to ecological problems, several times we discussed and prepared a report about ecological issues, particularly about the green economy, about solar, wind energy, and we are still interested in this issue. And in future, once again, we'll discuss. Once again, thank you very much for your kind attention and for invitation. It was a privilege for me to be invited here and have presentation. Thank you.
Thank you for you.
Thank you very much. Now, have any question? No. Да, please.
Professor Asaf, remain. I invite you in Chisinau next time.
You know, but
we met you. We visited sometimes, but this is a time you must desist to come in Chisinau to be together with us.
Yes, definitely I'll come because, you know, but I love Moldova, I love Chisinau, there are a lot of my friends, and I promised to come to the conference, but unfortunately just at night I came back from Budapest where I had meeting with the Speaker of Hungarian Parliament, and so I could not come. Definitely I will use any opportunity to come to Moldova because I would say, you know, but the most important conception in Moldova, this is people who lives in Moldova, who are very hospitable, who are very warm, very kind, and I wish you prosperity, peace, and hope soon come back again to Chisinau. Thank you. And drink wine, of course. Thank you.
Yes. Thank you.
Thank you very much.
So we finished this part of our session. Now we will have a break for lunch and see you at 2 p.m. after.
Dr. Nastas, can I speak with the Professor Academician Agabekov?
Yes, of course.
if you in the link of our conference. If he is the link. Academician Professor Agabekov.
Academician Agabekov, if you hear us, I don't know.
Okay. Good.
No.
Maybe we'll speak in afternoon.
Possibly. Thank you very much for your intervention. So we'll have a break for lunch, and we will come together online after break lunch, and we'll continue our session with last presentations. So we will ask you to connect with you after 2 p.m.
Just a minute. Hello.
Oh.
I would like to speak with Professor Duka. Is it possible?
Yes, it's possible. Just a moment.
Okay.
Just a moment. He was here with us, but now we'll call him to connect.
I heard that he asked about me.
Just a moment.
Да, сейчас этот Дука разговаривал, он сказал, могу ли я поговорить с академиком Агабековым. Я это услышал. И вот соединяюсь, а он что-то они не могут меня соединить с ним. Он уже ушел.
Прошу прощения, а когда начнется продолжение сессии после обеда?
2 часа, 2:15, наверное.
А он ушел уже, да?
Он вышел, вот он вам звонит.
Это он мне звонит, да?
Наверное, да.
Да, он вам.
Алло. Да, дорогой Георгий, так я вот подключился. Я подключился к конференции. Ты можешь подключиться? А ты вышел уже. Ну, да, если можешь подключись, тогда я хоть увижу тебя. Я от всей души хочу... Ну, давай. Я ему скажу, что мы ему галстук найдем, галстук хороший сделаем.
Алло, ну все.
Алло.
Здравствуй,
дорогой.
господин Агабеков.
Во-первых, я хочу тебе сказать, что от всей души, искренне, от моего имени, от имени наших сотрудников всех, от министра образования, господина Иванца, ты теперь понял?
Да, я понял.
Министр образования.
Приехать, а потом вдруг сказал, что не может.
Да, с твоей помощью, с твоей поддержкой, ну, все же оба стали членкорами, и наш директор.
Спасибо. Благодаря вам.
Да, самое главное, я показывал вот это твое посещение нашего института. Ну, все до сих пор, наши, особенно женщины, до сих пор тебя помнят и до сих пор говорят, что это ученый с открытым сердцем и твой непосредственный интерес. Ну, и я показывал, так сказать, может, не видел, показывал эту нашу доску, где ты наш почетный доктор. Дорогой Георгий, от всей души тебе, всей семье. И я надеюсь, что все же эти смутные времена пройдут, и мы встретимся. Но я тебе хочу сказать, я не забыл твой подарок. Я не стал это уже говорить там в обществе, что вначале мы с тобой сфотографировались, ты при галстуке, а потом вдруг стал без галстука. Все никак не могут понять, в чем дело. Но я тебе тоже, мы с нашим директором тебе тоже подготовили подарок. Тот же галстук, но только он особенный.
Хорошо.
Вот при встрече мы тебе обязательно его передадим.
Спасибо.
Дорогой, от всей души.
Спасибо.
От всей души обнимаю тебя, поздравляю тебя.
Спасибо.
Всего самого-самого доброго. Ты великий человек. Самое главное, что ты открытый человек, очень сильный. И я не премину тебе сказать, я вчера с огромным удовольствием прослушал твой доклад. С огромным удовольствием. Очень хороший, сильный. И я рад, что я начал работать. Ну, это Андрей начал. Я начал работать вот в области охраны окружающей среды по фентонным процессам. Вот
тоже интересно.
Это, да, это интересная вещь. Я думаю, что я своих учеников некоторых приглашу.
Очень рад, очень рад. Спасибо за поздравления. Спасибо
Георгий,
за то, что мы смогли
я
увидеться.
очень искренне от всей души тебя обнимаю. Ну, такая ситуация. Я переболел.
К сожалению.
Я еще болею до сих пор коронавирусом. Но я пришел ради, так сказать, чтобы тебя поздравить.
Спасибо большое.
Поздравляю.
Я всегда вспоминаю нашу встречу в вашем институте и в вашей Академии наук. Это были замечательные встречи, у вас замечательные люди. Они очень добродушные, очень гостеприимные. Они как будто наши братья. Вот мы с вами, с белорусами, очень похожи.
Да, точно.
Мы действительно поэтому и компатибельны, поэтому мы друг друга очень быстро понимаем. И я очень рад, что я стал вашим доктором Норис Кауза. Я хочу сказать вам, что мы тоже вам готовим сюрприз для вас лично и для Иванца. Я надеюсь, что ваши химики будут вместе с нашими химиками.
Да, и вот что ты мне напомнил, Георгий, что я тебе хотел предложить и обсудить.
Да.
Значит, у меня возникла такая идея примаан сделать совет химических обществ. Это совет химических обществ примаан. Значит, и я предложил бы туда, но на твое усмотрение, я не знаю. Значит, председателем вот этого совета начать с химических обществ. Я обсуждал это с Гусаковым, с нашим президентом. Он это поддержал. Но я не знаю, как объединить там географическое общество. Я говорю, давайте начнем с химического общества.
Да.
И если бы я тебя предложил, значит, сопредседателем, ну, во-первых, там нужен обязательно от Беларуси кто-то.
Ну, вы от Беларуси, вы, может быть, будете.
Это я могу. Значит, от Молдовы вас. И я вот не знаю, я советуюсь с тобой. Что ты скажешь? Я, так сказать, разговаривал еще с Цивадзе, с российского химического общества.
Он там председатель там.
А?
Он председатель там.
Я знаю, да, так я МААН хочу сделать, чтобы председателем были, чтобы председателем МААН было. Я хотел сначала Славу Хакташечка туда ставить, но что-то такое они не... Как ты на это смотришь?
Нет, Цивадзе очень сильный. Он долгое время был директором Института общей химии, и он очень сильный ученый, у него очень много и... Только... Он сейчас уже не директор, по-моему, несколько лет.
Он не директор, так они все сейчас научные руководители. Я тоже сейчас почетный.
Не, он очень хороший, мы знакомы с ним, он очень хороший.
Не, ну тебя все уважают, и тебе все, ты знаешь, как к тебе относятся. Ты очень приятный мужик, очень приятный.
Да, очень приятный. Хороший химик и очень приятный мужик.
Ты! А не Цивадзе.
Ну и Цивадзе тоже. Мы оба хорошие.
Ну я с ним недавно встречался. Мы встречались с ним в Грозном, я был. Это Хаджиеву было, так что там открывали доступ. Я очень рад. И мы ждем тебя в любое время.
Спасибо. Я надеюсь, что это все закончится и откроется возможность.
Обязательно.
Потому что сперва пандемия на нас напала, а сейчас уже вот это нас...
То есть я, значит, это профессор, я могу, значит, поговорить с этим, что я с тобой разговаривал.
Да.
По поводу совета, и Мартиросяном я разговаривал, он поддержал. Ну, поддержал, значит, этот Журинов.
Да, Журинов. Он президент Академии наук и председатель общества химического, да, там в Казахстане?
Вот мне кажется, я не помню, он председатель общества или нет. Я знаю, что ты председатель общества. Да,
я в Молдове
я знаю. И я уже разговаривал с председателем, и я больше придерживаюсь, чтобы все же была Молдова.
Ну, пожалуйста, я не возражаю. Ну, я думаю, что мы должны чуть-чуть повременить, чтобы закончились вот
я полностью с тобой согласен.
Вот эти напряженные отношения, потому что так, у нас тоже тут, вы понимаете, да, тут и Дога, мой очень хороший друг, большой композитор, ему исполнилось 80 лет, и эти с телевидения, с радио, они там дали нас, но сейчас очень много говорят об этой, то, что сейчас происходит.
Да, это сейчас такая
и поэтому тут они, давайте мы, я думаю, что подождем, но я согласен, чтобы вы знали.
Не, мне это нужно будет где-то, они планируют так, я не знаю, как в связи с теперешней ситуацией, они планируют где-то в Москве в сентябре месяце провести вот этот опять совет научных обществ. Не совет научных обществ, а совет МААН. И вот там мы можем...
Там же ваш Гусаков.
Да, я могу уже сказать, что я разговаривал с вами.
Хорошо, я согласен.
Предложение дать и все.
Ну,
дорогой, я тебя от всей души обнимаю. Поздравляю.
Я вас также обнимаю.
Твоей семье. Всем всего самого-самого доброго.
Вам также здоровья, всего хорошего и успехов на благо нашей химической науки.
Да. Всего тесно. И я надеюсь, что все же я как-то с Иванцом мы разовьем это. Вот мне понравился твой доклад, и мне понравилась эта область. Я
может быть, и как-нибудь, если все это успокоится, потому что я уже имею приглашение, значит, поехать в Румынскую академию сделать доклад, там, в один университет.
Ты же академик Румынской академии.
Да, я академик, но они меня уже пригласили. Но они другой доклад хотят. Они хотят доклад об экологической химии сделать.
Это твое. Вот этот доклад мне очень понравился.
Это вся моя жизнь научная.
Да.
Это еще такой был профессор Сычев Алексей Яковлевич. Он заведовал кафедрой физической химии, после него я заведовал кафедрой физической химии. И они занимались. А в Москве в Институте химфизики Пурмаль такой был, Анатолий Павлович.
Да, Пурмаль, я знаю.
Курлатов, потом Травин. Вот мы сотрудничали вместе. И у нас был проект совместный с американцами. Ездили туда, делали хорошие работы с американцами. Но меня, когда в 1982 году я сделал доклад, значит, на конференции по катализу в Ленинграде, то, значит, там присутствовал Маркус, лауреат Нобелевской премии, который получил перенос электрона. И вот в 1982 году он пригласил меня там в ресторан поужинать и пригласил меня поехать в Америку на стажировку на год, провести совместную работу. Так у меня были такие проблемы с КГБ, они начали говорить, что я продался. И у меня лет 8, по-моему, меня не пускали ехать за границу. Я говорю, слушай, он мне предложил, я хочу с ним, потому что у нас совместно работать. После того и ректор на меня тогда напал. Как ты, неужели ты хочешь уехать, остаться там, ты же патриот. На меня так набросился. Так, в 1992 году, когда, значит, он получил Нобелевскую премию, меня сразу направили за границу. Да. Хорошо.
Понятно. Ну, в общем, мы это все тебя отметили в твоем. Ну, мы тебя ждем. И твой тай твой ждет.
Ага, спасибо.
Он особенный, он не такой, как ты мне с намеком подарил. Я вспоминаю.
Я считаю, что химические связи между странами, республиками Советского Союза, они были очень сильные. Очень сильные. Я хочу сказать, что они остались. Потому что вот наше поколение еще есть. И я думаю, что мы имеем возможность сохранить эти связи и сделать еще много полезного для химии.
Я хорошо помню нашу встречу, я не знаю, ты помнишь или нет. Это был 86-й, 85-й, 86-й год, в химфизике мы были. Я тогда тоже там был, я как раз готовился, так сказать, к защитам там всяким. проектом. И я вот тебя тогда увидел. Молодой, красивый мужик. Ну, ты остался красивым что-то. Наши женщины до сих пор тебя вспоминают. Ты видел вообще презентацию, вот твои фотографии, которые я показывал?
Нет. Когда?
Пускай покажут тебе. Я думал, что ты видел. Там я же показал твое посещение нашего института прямо в моей презентации.
А вы не можете это послать мне?
Пошлю.
Пришлите на мой адрес, я посмотрю.
Хорошо, я тебе пришлю твою эту презентацию вместе с этим. Все, Георгий, большое тебе спасибо.
Спасибо вам. Всего доброго.
Всего доброго. Семье большой привет и здоровья вам всем.
Спасибо. Вашей семье тоже большой привет. И всем коллегам из института.
Спасибо. Всего доброго. Да. Привет, Нина. Ну, я понял, а я сейчас только с Георгием Дука вот кончил разговаривать, что сейчас еду домой. У меня температура опять 37, да, 37,4, что-то хера знает. Ты лучше скажи мне это, что вам купить? Цветы покупать? А ну, хотя бы аленький цветочек может быть.
Владимир, пожалуйста, выключите микрофон, потому что все слушают, что вы говорите.
Сейчас.
Спасибо еще раз. Привет вашей супруге.
Если хотите потом, чтобы не так холодно, там в 22-й комнате, можно просто зайти.
Спасибо.
Меня показывают.
Там все тебя видят, кстати. 9 участников. Сейчас выключу микрофон. Dear participants, how can you hear me? Please confirm if you can hear me well. Does anybody confirm that? I just would like to be sure. Okay, great. So we will. Yes, we hear you. We will start our session 10 minutes later to have more participants online and in this room. We have at least one presentation which will not be presented today, so we have some time for some time to wait for others. Well, I would like to check this list of presentations. I will be first, and next one will be by our program. Dr. Hatis Ezer Okten, Turkey, if you are here, I can see you.
Yes, I am here, Professor.
Okay, thank you very much. We are waiting for you after you will be second presentation today. Dr. Vyacheslav Shvitky, if you are here, please confirm your participation. Dr. Michael Nazarkovsky from Brazil, possibly he will join us some later because time difference between us and Brazil is really significant, and I'm sure that he will join us very soon. Daria Pechonka from Belarus, are you here? Not yet. Okay.
Я есть.
Есть.
Hello.
Мы вас ждем. Okay. Okay. Everything goes smoothly, as I can see. Дарья, как вы смотрите на то, что мы вас переставим вперед, если наш участник из Бразилии, скажем, ему нужно быть не раньше 3 в связи с разницей во времени?
Прямо сейчас или чуть попозже?
Нет. 3-й доклад по счету.
Окей, без проблем.
Хорошо, спасибо. Well, 5 minutes and we will start our session. As I can see, we have 12 participants online. That's great. Well, let me start our session B to continue our presentations. We are working despite of impossibility to join physically most of our participants because of war started by Russia. I should say I'm from Ukraine. I appeal to everyone who is here, to our colleagues. Russia bombs Ukrainian cities. Russia destroys civilian buildings and kills civilian kids, women. Please stop it. Please be together with Ukraine in this hard time for our country. Thank you. Now I will start my presentation. I'm Alexander Goncharov. I'm working in Ukrainian Scientific Center of Ecology of the Sea. This presentation is prepared with my colleagues from Kuwait Institute for Scientific Research, based on our investigation, geochemical investigation of biogenic sands of Persian Gulf. Let me share my presentation. This is about some modification of very specific sediments exist on the coast and some other substrates mainly formed by having biogenic origin. I mean origin of calcium carbonate as a part of shells or of mollusks, shells or cells of protozoa and like this. Some materials of destroyed corals, and exist very well-known method of determination of organic carbon in soils, and this is very simple method based on difference between weight before and after combustion. High temperature combustion, the procedure of determination and final result can be calculated by this formula: initial weight, dry weight, and weight after combustion multiplied to specific coefficient. And this is semi-analytical method. It has some certain deviation from real value, but not too much. And this is very simple and a very fast method, and it is widely used in the world in all labs. First, what you should do, you should dry the sample in the dry box under at 150 and 105% degrees Celsius to dry out this sample to avoid any water in this sample. And then these ceramic pots are placing into muffle furnace, and this is, you can see a left picture, and on the right picture you can see combustion process. This picture taken with open doors of muffle furnace. Exists some range of temperature between 450 to 950. In my opinion, 950 is not optimal temperature, because this temperature is a peak for release of carbon dioxide from carbonates, and this high temperature is not very good, and maybe more appropriate is a range between 450 to 650. Anyway, what you should do with these samples, after cooling this ceramic pots with sampling with samples, you transfer it to the balances, fix final weight, and then make your calculation of organic carbon in certain sample. But exists some problem connected with this method. Exists so-called biogenic sand or some silty fractions of bottom sediments, which contains a lot of biogenic materials, which contains such kind of rest of biogenic materials. You can see shells, some invertebrates, corals, and there are different fractions. You can see fractions bigger than 1,000 micrometer, and then between 500 and 1,000, and less and less and less. And you can see the smallest fraction after the sieve procedure I took by microscope to show you how small could be the particles of biogenic materials in sediments. This is just an example of really totally carbonate sediments, but in real situation exists some inclusion of some particles like some shells and other rests of diet organisms, which can affect your final results because of release of carbon dioxide, CO2, from carbonates under the high temperature, what I told you above. And exists a method how to neutralize this carbon dioxide using diluted hydrogen chloride, and this method allows to eliminate carbon dioxide from sample, and it looks like this. When you add some acid to carbonate, it makes basic and acid solution, and neutralization of this solution makes to bubbling of your sample, and you can see this effervescent, and these bubbles are carbon dioxide. So it looks like sparkling water with bubbling. It looks like boiling of water. So you eliminate carbon dioxide, but you get carbon chloride, which is highly hygroscopic. And the problem of future treatment of the samples, it is the problem connected with highly hydroscopic properties of calcium chloride. And when you even waiting on balances your sample, this sample extract water from air, and you can see on your balances as your sample get more and more weight because of extracting water from the air. What we should do with that? How to avoid this? First, I propose the scheme of Poch ways of carbon dioxide and water when you treat such sample. You can see that this is a sample. I mean, this core with a carbon, organic carbon, and calcium carbonate. You can treat it with acid, and you can get some carbon dioxide, which goes to air, and get some calcium chloride with water. This water should be eliminated by drying, of course. Then, after when you treat the sample in the muffle furnace, part of organic carbon goes to create carbon dioxide, and this is what we are looking for when we treat sample to estimate organic carbon in the sediment. But part of calcium carbonate goes to calcium oxide and also carbon dioxide, and this is our harmful influence, and this is our uncertain harmful influence which affect the accuracy of our result. When we treat this calcium oxide with HCl, we also get calcium chloride, which goes to the pool of our calcium chloride obtained by the previous treatment. So at least it exists two ways to treat the samples: before and after combustion, right? When we add water, some basic like calcium OH2 creates, and then treatment with HCl also lead to formation of calcium chloride. And you can see below some properties of calcium chloride with different content of water. You can see that calcium chloride under the temperature higher than 250 degrees is absolutely without any molecules of water. So it is free of water, but this is a really high temperature. You cannot use this sample for your operation, for balances, because it is danger. It can destroy your equipment, right? But room temperature is absolutely overflowed by air water, and it looks like your powder, I mean calcium chloride, is flowed by water which are extracted from air. And exist some intermediate states higher than 30 degrees. This is calcium chloride with 6 molecules of water. And then the next range, this is 45 degrees, and this is this molecule contain 4 molecules of water. Between 45 and 175, just 2 molecules, and 1 molecule is between 175 and 250. But we cannot consider the range between higher than 60 degrees, because this is too hot to operate with that. But what we should do, how to solve this problem? First of all, we should use blend of calcium chloride. This is powder what you can buy in as a chemical. It can be in any lab, and you can do this blend and all operation in pair with the same temperature. You use blank and your sample and operate with both of them. And when you make measurement of weight on balances using your sample, after that you use calcium chloride to control degree of hydrization of this molecule. I mean, under the certain temperature and air humidity, you always have different values of water in the molecule with molecule of calcium chloride. So use of this blank is our solution to be sure that amount of water connected with calcium chloride is controlled by your experiment, right? But exists some additional approach. Maybe we can use HCl after combustion. First, in this approach, if we suppose that we can do this, first we should understand that part of calcium carbonate is already oxidized and we have harmful influence. If not, if a temperature is comparatively low and you are sure that it is not happen or happen less, you can do treatment before and after. And I made some experiments with addition of acid before treatment and methylphenolate after, and you can see the result. Microscopic picture of native samples with HCl, and after you can see that some silicates are the same. Totally, the picture look similarly. This is our experiment of treatment of sample before and after combustion. You can see that they show the similar results, and you can see do both exists some also suppose that some combustion can make some micropore on your sample, and this pore could be like some sites to which makes which change the physical-chemical properties, and air, water can be extracted from air by differently, but as you can see by this plot, actually these values of humidity taken by different even grain size before and after adding HCl, before and after combustion, are similar. So I can say that there are no any reasons to treat your sample after combustion because of two reasons. You can lose some CO2, carbon dioxide, because of oxidation of carbonates, and you will have no any advantages because all our experiments shows that properties did not change after the high temperature treatment. Thank you for your attention. I would be happy to reply your questions. Okay, if there are no questions.
Алло, а можно по-русски спросить?
Да, пожалуйста.
Коллега, а почему вы вот такую сложную операцию делаете по удалению СО2? Нельзя ли его просто измерить на выходе? Потому что любая молекула кальция там содержит СО3, там, да, и в принципе пропорционально будет концентрация.
Да. Если такой совершенно справедливый вопрос, и я ждал, что его зададут, и спасибо, что вы это сделали. Действительно, есть метод улавливания углекислого газа после обработки соляной кислотой образца. Но тут есть некоторые методические моменты и технические. В ряде лабораторий нет возможности, или там это, скажем, сложно, или персонал не обучен это делать, но в данном речь даже не об этом, а о том, что есть очень высококальцифицированные такие осадки. Это довольно сложный и длительный процесс, его измерить можно, и я бы предпочел при возможности делать именно так, как вы предлагаете. И моя тут как бы на самом деле, моя пропозиция, она состоит скорее для тех лабораторий, у которых вот есть в наличии вот только там весы и муфельная печь. Все, то есть как бы для того, чтобы избавиться от карбонатов вот таким путем без измерений, да, который тоже требует там определенной дополнительных оборудования, колб, там, индикаторов или там титрования и так далее. Вот это как бы некое упрощение, хотя оно имеет свои тоже ограничения, но в целом, как бы, если есть возможность в лаборатории это измерить прямым путем по выделению углекислого газа, лучше сделать именно так. Вы тут совершенно правильно задали вопрос.
Понятно, спасибо. Все.
Спасибо. Okay, if nobody wants to ask more questions, I have a pleasure to invite our colleague from Turkey, Dr. Hatice Eser Okten. You are welcome.
Hello.
Please share your screen.
Yes. Can you see my screen?
Yes, yes. Thank you.
Perfect.
You're
Thank
welcome.
you. Thank you, Professor, for inviting me. And it's my pleasure to be a part of this conference. So I would like to present our work at Izmir Institute of Technology, and I bring many greetings from Izmir Institute of Technology to Moldova and to Ukraine and to everyone. Our title is we are interested in the boron removal from geothermal water using a hybrid microbial desalination cell reverse osmosis process with energy production. So my contents will be starting with the introduction and why we are interested in the geothermal water resources. What we're trying to do here is we're trying to tackle two environmental problems, one of them being the geothermal water resources being dumped into the environment after their energy is acquired. As you know, geothermal brine is high in salinity, high in ion concentration, so uncontrolled, without treatment, dumping of geothermal brine into the environment, which sometimes happens in Turkey, is a big problem for especially agricultural areas. And on top of that, in the era of climate change, we are dealing with severe water scarcity, water stress. In Turkey, we are also prone to water stress. And in Turkey, almost 80% of abstracted water goes to the agriculture sector. So we are trying to shift the paradigm, shift to unconventional water resources using a bioelectrochemical system, namely microbial desalination cell, to be able to treat boron from geothermal water resources and propose it as a remedy to to scarce agricultural irrigation purposes. We will be sharing our results and discussion and conclusion, and I will be I promise to be within the time limit. So we all know that water stress by country, the world map, the water stress, expected water stress by 2040 is expected to be in the extremely high percentages in Turkey. So we need to get ready for problems, and we need to think about solutions. And also agricultural exposure to water stress. As you can see, Turkey is not in a good condition too. We are located in Izmir, in the vicinity of Aegean Sea, and we have water scarcity problems and seawater intrusion to groundwater wells too. So that's a problem. What we're proposing is shifting from conventional to unconventional water sources, because when we go out into the field and talk to the farmers, they're saying that they need to dig their wells deeper and deeper every year and spend more money, and more money is also spent for the electricity, for the pumping of groundwater. So we started thinking about how about using wastewater, treated wastewater, for agricultural irrigation. And also the Aegean area of Turkey is blessed with geothermal resources, and we also are aware that sometimes those geothermal brine are being dumped into the environment without treatment, and that has a severe environmental effect, and also it just hinders the crop efficiency. So we would like to look into the characterization of water samples we have at hand. We have geothermal water in the Izmir area. It has 11.9 milligrams per liter of boron in it, and re-injected geothermal water has 11.3 milligrams per liter. The reverse osmosis diluate has 7.46, and our reverse osmosis concentrate has 15.1 milligrams per liter of boron. Why reverse osmosis? Because reverse osmosis is the mostly used desalination technology. It's used in the industrial scale, and treating geothermal water, nanofiltration and reverse osmosis are the two industrial scale used treatment options. But just single pass on a reverse osmosis system does not meet the standards or the requirements, the criteria for agricultural treatment. Therefore, we were looking into it if we would be able to use another system we can couple with a reverse osmosis system, and we can either use it as a preliminary treatment to reverse osmosis, or polishing of reverse osmosis effluents. So for this presentation, we were looking into the polishing part, the post-treatment of reverse osmosis streams. And there, as you may well know, there are two streams from RO, one of them being diluate or permeate, and the other being concentrate. So the reverse osmosis challenges are like high capital and operational costs. Well, Turkey is not a membrane producing country, so we need to pay in US dollars or euros, and it's a big setback for us. Also, high waste sludge formation, membrane fouling, scaling is a problem, high energy consumption, and sometimes not sufficient treatment efficiency. So as I mentioned before, we were looking for another environmentally friendly and energy sufficient, like energetically self-sufficient technology to couple RO with. So we end up with the bioelectrochemical system, which very much resembles to a microbial fuel cell. Just it has another compartment for desalination. You see in the figure here, we have the microbial desalination cell. And microbial desalination cell we used is a 3-compartment system. And there is the anode compartment, and in the middle there is the desalination compartment, and then there is the cathode compartment. And the anode compartment and the desalination compartment were divided by an anion exchange membrane, and the desalination compartment and the cathode compartment are divided by a cation exchange membrane. And the anode and the cathode are connected through an electrical wire, and we used an external resistance. And we did not, the system was producing its own energy from microbial activity that's been provided in the anode chamber. We were feeding anode chamber with a high organic content yeast wastewater, and we were keeping it anaerobic so that whatever energy, whatever electrons were produced by the microbial consortium in the anode chamber would be given to the wire through anode electrode. For this, we were looking into the MDC application, coupling with reverse osmosis, permeate and concentrate water treatment. So to be able to do that, we were looking into the operating parameters and for boron and COD removal in the anode compartment. As I said, that we fed anode compartment. This is a fed batch operation, by the way. We fed the anode compartment with high organic content yeast wastewater, and we also took some sludge, activated sludge from the same facility to put into the anode compartment. And we were measuring the treatment of yeast wastewater by measuring COD removals. We have checked initial boron concentrations of 5, 10, 20, and 30 milligrams per liter. We have checked catalyte solution, different catalyte solutions, phosphate buffer solution, tap water, and acidified water as the catalyte. We also checked different airflow rates that are provided to the catholyte. So that we were seeing that providing an effective electron acceptor such as oxygen in the catholyte, in the cathode chamber, if it would actually draw the electrons through the wire itself, through the circuit, electrical circuit itself. And we also checked the analyte solution temperatures, 25, 40, and 60 degrees Celsius. We couldn't get much higher because we were using membranes, and the membrane characteristics would change. Electrode surface areas of 18, 24, 36, and 72 square centimeters were used for anode and cathode electrodes. And we also, investigated activated sludge to wastewater ratio for anode compartment of 1:5, 1:2, and 1:1. Also, we studied the energy production under fixed external resistance of 100 ohms. And the voltage values were the electrical potentials that had been created by the system were recorded by a multimeter, and power density values were calculated accordingly. And on the right-hand side, you can see our small MDC. That's the lab scale, one. And the optimum conditions were found as the electrode surface area being 36 square centimeters. Catholyte solution, phosphate buffered saline solution gave the best performance. Activated sludge volume of 1:1 and temperature 40 degrees Celsius and airflow rate of 2 liters per minute gave the best optimum conditions. Prior to these were the preliminary results from the preliminary data. And then we started with RO concentrate water, and we, as I said, this was a fed batch reactor. What we did is every 12 days, we draw out the, let's say, spent yeast wastewater, and then add fresh wastewater to the anolyte, to the anode chamber. And as you can see, the effluent boron concentration has dropped from 15.1 milligrams per liter to 3 milligrams per liter at the end of the third cycle. And boron removal efficiency was 80% at the end of cycle 3. And COD removal in the anode chamber, while RO concentrate experiment was being run, were dropping from, remember I said it's a high organic content yeast wastewater, so the COD was above 9,000 milligrams per liter. So we see a pretty good removal of COD during the cycles, and the performance did not really change significantly over the cycles. So that means that the Microbial consortium was doing its job properly. And further removals from RO concentrate, we have also looked into the arsenic concentration, because the RO, the geothermal water has arsenic in it, and in the concentrate, it is in the concentrated form. So the effluent arsenic concentration has dropped to null in the third cycle, and the lithium concentration has dropped to 0.251 milligrams per liter from 3.3 milligrams per liter. If we look into the RO permeate, the boron removal from RO permeate, we have achieved 56% boron removal efficiency at the end of the third cycle. 100% arsenic, aluminum, and iron removal efficiencies were achieved, and the lithium removal efficiency was almost 72%, and the chromium was 98%. We also checked those for permeate too. When we look into the energy production, we have seen that the voltage, the electrical potential production in the system was very similar for the cycles, as you can see, around 900 millivolts for RO concentrate, and around 700, like 690 for RO permeate. And from that, we calculated the power density values. You can see on the right-hand side, and for the power density, the RO concentrate was expected higher than the RO permeate. In conclusion, well, MDC RO hybrid process is an environmentally friendly and energetically self-sufficient solution due to the MDC, because MDC is energetically self-sufficient. So MDC has the potential to be used as a polishing post-treatment step for RO streams, or it can also take place of preliminary treatment for RO. The boron removal efficiencies were 80% for RO concentrate and 56% for RO permeate, and the electrical potential and power density values for RO concentrate were 890 millivolts and 2,220 milliwatts per square meter, respectively, and the RO permeates, these values for RO permeate were slightly lower than the values for RO concentrate. We also looked into the SEM and EDX results, and they confirmed the presence of microbial biofilm and coarser grains agglomeration on membrane surfaces. So this is my presentation. I thank you for joining in, and I would like to take if you have any questions.
Dear colleagues, does anyone have questions? Okay, I have a question first.
Please.
This is not a big secret that river osmosis membranes has a microbial biofilm, right?
Yes.
And my questions is about possible pH range for your technology? I mean, what is the highest and lowest value to be effective in this process? Maybe you expect or...
Yes. Oh, yes, yes. So the pH range is that's a very good question, Professor. Thank you so much. Because for the boron to be removed using an anion exchange membrane, the boron should be in the negatively charged. So in geothermal water or in natural waters, boron is found as boric acid, which is not charged at all. For boron to be charged, you need to increase pH over 9.5 so that the actually the boron becomes borate ion, a negatively charged ion, that it has 4 hydroxide attached to it, and only then it can be removed using an anion exchange membrane. And in our desalination cell, we try to keep our pH above 9.5, almost close to 10. And we know that the membranes that we use actually, perform well up until pH 12. So, I mean, but that's the value given by the manufacturer, and you don't want to go up there. So that's a very good question. And also we are seeing that in the catholyte, some hydrogen peroxide is being produced. We haven't gone into that in detail. We haven't investigated that, but we are also thinking about some configurational changes to make use of that hydrogen peroxide to use as an anti-fouling agent. So we'll see.
Okay, so does a boron system, a buffer system of water, affect these changes of pH?
Yes, in the in all natural waters there's the carbonate system, and in geothermal waters, yes. But what we do is we are changing the pH by adding sodium hydroxide externally. But right now we are also trying to integrate a Dunning dialysis system to the MDC system, so that it will, by stripping, it will, self-adjust the pH. Hopefully, we're working on it.
Okay, thank you. This is great. Sure. Direction of applied science.
Thank you.
I really impressed. Thank you for your.
Thank you, Professor. Thank you.
Okay, well, if Dr. Vyacheslav Shitky is not here, we are going to Daria Pichonka. If I'm correct, are you here?
Yeah. Sure.
Yes.
Daria, please share your screen.
Dear organizing committee,
do you see my
participants of our conference, I am pleased to welcome you to this representative forum of environment and sciences. Меня видно? Ну, в смысле, слайд.
Да.
Thank you. Ну, пользуясь случаем, я хочу сказать несколько слов нашему руководителю Георгию Григорьевичу Дуке и его верным помощникам по организации этой конференции, которая уже проводится 7-й раз и всегда вызывает большой энтузиазм. Так получилось, что Георгий Григорьевич стал первым официальным руководителем моей научной работы на соискание ученой степени. И эта совместная работа дала мне стержень и уверенность в дальнейших научных успехах. Я с теплотой и признательностью сохраняю нашу дружбу и желаю Георгию Григорьевичу крепкого здоровья и новых достижений в области экологической науки, которой мы преданы всю нашу жизнь. Well, my report is new aspects of the estimation of state of the nature of water and its influence on bio-objects. The co-authors are my colleagues, from various academic institutes of the Russian Academia Sciences. The natural aquatic environment is a multi-component open-type system. With the advent of analytical capabilities to determine the parameters of the aquatic environment, research is constantly being carried out to access water quality. Every year.
Вашу презентацию не видно. Не могли бы вы запустить ее снова?
Сейчас попробую. Сейчас видно?
Да.
It's the first slide. We can see our name of our report and authors of the report. Natural water is a multi-component open-type system, and with the advent of analytical capabilities for determining the parameters of the aquatic environment, research is constantly being carried out to access water quality. Every year, up to 1 million new synthetic substances are recorded per year, which in one form or another enter the aquatic environment. The system for determining water quality, which is based on a combination of individual hydrochemical indicators, is no longer able to reflect its current state. But it is still used in the laboratories of regulatory authorities. To access the quality of natural water, its biological usefulness, other approaches are required. Now your attention is presented to a new biochemical approach to solving the assessment of water quality. There is a need to find faster methods for assessing the quality of natural water and to develop model system for these purposes. From this point of view, the most promising models are those interconnected with a system of regulation of oxidative processes. This follows from experimental data. The stationary of oxidative processes is necessary to maintain the balance of redox reactions in an aqueous medium. The system of regulation of lipid peroxidation is the basis of environmental monitoring. Toxicants disrupt the regulation of lipid peroxidation regardless of the way biological objects enter the body. Aim of this work was to study the physiochemical properties of the natural water from different sources and to evaluate its influence on the biological membranes using ability of the natural phospholipids, one of the base components of membranes to form nano-sized particles in the polar medium. Lecithin was chosen as a model system of biological membranes due to its ability to spontaneous aggregation in a polar environment. The slide shows the structural formulas of the main fraction of lecithin, phosphatidylcholine, and the proportion of minor fractions of phospholipids. Then the composition of lecithin from different bases varies as in any natural object, but the main share of phosphatidylcholine usually exceeds 80%. A 10% soy lecithin solution from Biolek, Ukraine, was used as an analog of natural phospholipids. The fractional composition of its phospholipids was determined by thin layer chromatography. To carry out research is on natural water, samples were taken on the territory of the Voronezh Reserve and the Don River. The Don and Usman rivers, as well as shown in the background, and areas subject to anthropogenic pollutions, were chosen as a natural water probes for the study. Along the Usman River, a section was made along the meridian direction from north to south, for about 30 kilometers. This table presents the results of analysis of hydrochemical parameters in the snow, in the rivers Don, Usman, and in the well of the floodplain of the river Usman. There is a downward trend in the concentration of biogenic elements from north to south for rivers Usman and Don River in the Novozhivatina area has relatively low hydrochemical parameters compared to River Usman. We can compare Don River and River Usman. Large differences are seen in snow samples taken in conditionally clean places and in places with anthropogenic load near the highway. It is characteristic that the high values of reduced forms of nitrogen in the snow near the road also indicate the direction of biochemical reactions of the transformation of mineral forms of nitrogen. The balances shifted to the reduction region. In the absence of nitrite ions, high concentrations of ammonium and nitrate ion here are observed. Lecithin in aggregation is an aqueous medium was studied by dynamic light scattering on a Z-sizer nano analyzer from Malvern Instruments, UK. As can be seen, in the presence of natural waters, the size of lecithin nanoparticles decrease twice, and the zeta potential sharply decrease. Here, decrease in the negative charge and particle size is accompanied by an increase in the content of hydrophobic compounds in natural water samples. The spectral characteristics in the UV region of the spectrum of the Don and Usman rivers are very close, but when decomposing the spectra by House method, a different number of maxima were identified in different ranges and with different values of optical density. The spectral characteristics of snow vary greatly depending on the sampling location. The spectra differ both in the absolute values of the optical density here and here, and in the qualitative and quantitative set of Gaussians. And this is due to the hydrochemical composition of the analyzed meltwater. Conclusions. presented two model systems, the main mathematic analysis of UV spectra of the natural waters using the Gauss method and the spontaneous aggregation of lecithin in distilled water and in presence of investigating probes of the natural water, allow us to use new possibilities to evaluation a state of the natural aquatic medium. The presence of various organic NNP containing compounds, even at low doses, leads to significant changes in the ability of lecithin to form nano-sized aggregates in an aqueous medium and zeta potential of membranes in biological media. The use of the Gauss methods for the mathematical analysis of UV spectra makes it possible to express evaluation of the chemical composition of the aquatic environment. A significant difference in the composition of snow in the background and area and near the highway is shown. In particular, the presence of reduced forms of nitrogen in the snow near the highway indicates fresh pollution and reducing conditions. Thanks for your attention, dear colleagues.
Dear colleagues, does anybody want to ask any questions? Okay, Dr. Michael Nazarkovsky is here. If not, Daria Pichonka will be the next.
Okay. Thanks.
Yes. Good afternoon.
Dear Vyacheslav, please stop your share. Okay. Daria Pichonka, please share your screen. We have pleasure to have your presentation.
Do you see my presentation? Do you see my presentation?
Yes, you just have to share for full screen and you can proceed.
Dear participants, dear colleagues, first I'd like to thank the organization committee for the opportunity to present our report. The research was carried out in the laboratory of Absorbance and Absorption process of the Institute of General and Inorganic Chemistry of the National Academy of Science under the scientific leadership of Dr. Andrei Ivanets. Relevance. Inorganic lithium ion safes are widely used as adsorbents of lithium ions from aqueous media. These materials are characterized by a high lithium adsorption capacity and excellent selectively against the background of completion ions of alkaline and alkaline as metals. Lithium manganese phenol are an excellent candidate for effective lithium ions adsorption. The work aimed to study the regularities of lithium 1.62, 63, manganese 1.67, oxygen phosphenyl synthesis, and to determine the main factors effect of the phase composition, structure, and adsorption properties of lithium manganese adsorbent. Task of this work to obtain lithium manganese by hydromethyl, solid and solid phase synthesis methods, to characterize lithium manganese spinels by XFD, FTR, and DDG techniques, to study absorption properties spinels and selectively to lithium ions. Methods of obtain spinels. Samples of spinels were obtained using hydromethyl, cell gel, and solid phase synthesis method. Hydrothermal synthesis was carried in an autoclave at 160 degrees 14 hours. Benzene and an aqueous solution of lithium hydroxide were used as precursors. Cell gel synthesis was carried from aqueous solutions of manganese acetate and lithium acetate with the addition of citric acid as a complexing reagent. The cell gel transition was carried by evaporation. Да.
Можно вас перебить?
Да,
У меня
слушаю.
ощущение, что ваша презентация она остановилась на первом слайде, и либо перезапустить ее заново, потому что мы не можем следовать вашим словам.
Хорошо. Странно, вроде бы все как надо. Сейчас попробую еще раз. Что видно?
Первый слайд.
А так?
Так видно. Но если вы сделаете на весь экран, будет лучше. Отлично. Но не весь экран. Вам лучше...
Так, видно?
Нет, вам нужно пойти в левый верхний, в левую верхнюю часть экрана, там начать сначала, там, короче, вот есть кнопочка. В PowerPoint. Вот, да.
Да, хорошо.
Ну, пока... Ставьте так, просто двигайтесь слайдами, будете переключать с одного на другой мышкой. Так хорошо.
The cell gel transition was carried by evaporation of the mixture and 110 degrees until the formation of a dark brown hydrogel, which was further heat treated at 150 degrees. Solid phase synthesis was carried from manganese acetate and carbonate lithium precursors. All obtained samples were calcined at 500 degrees for 5 hours. DTG was carried out from determination the chemical reaction occurring during calcination. Despite the fact the spinel samples have the same stoichiometric and qualitative composition, the temperature of formation phase spinel differs. In the solid phase method, the intermediate peak in the temperature range of 760 and 780 degrees. Cell gel method endothermic peak 700 and 850 degrees. Hydromethyl method endothermic peak 800 and 860 degrees. The methyl loss covers also different. Hydrothermal method from 7 to 9%. Cell gel method from 5 to 7%, and solid phase method from 10 to 23%. The XGD data proves the formation of lithium 1.63, manganese 1.67, oxygen for spinel for all obtained samples. The lithium manganese spinel prepared by salt gel has the most intense peaks. The table shows the crystal parameters of the spinel lattice. It can be noted that the samples obtained by salt gel and solid phase methods have a lattice parameters closer to literature data. According to the literature sources, the value of the parameters is 80.20. The air spectra of lithium manganese spinel shows the presence peak and 529 centimeters attributed to symmetrical deformation vibrations of the manganese octahedron. The intense peak at 656 centimeters was attributed to asymmetric deformation vibrations of the manganese octahedron. The peak of about 1045 centimeters was attributed to stretching vibration of the band lithium oxygen. Also, air spectrum was shown on the slide. Air of lithium manganese spinel obtained by treatment 0.1 hydrochloric acid proved the formation of ash forms. It can be noted that it is obtained of the band lithium oxygen. Using nitrogen desorption adsorption, which was found, the obtained samples of lithium spinel, lithium manganese spinels the first substance. The obtained isotopes belong to the UPAC classification type 4. The sample obtained by salt gel synthesis has a low specific surface area of 5.57 and average point diameters of 384 nanometers. The slide shows the results of adsorption. The adsorption experiment was performed in wet conditions with 1,000 milligrams lithium fluoride solution, and the ratio volume and mass 150 milligrams liters. Lithium spinel adsorbent prepared by salt gel method had high adsorption capacity 80.5 millimole gram and removal efficiency 32.8%. Lithium manganese spinel adsorbent prepared by solid phase method had low adsorbent capacity 60.4 millimole gram. Conclusions: lean manganese spinels with structure on lithium 1.63, manganese 1.67, oxygen 3 were obtained by of solid phase, salt gel, and hydrometallurgical methods. The formation of spinel lithium manganese with structure was brought by XRD and air spectroscopy analysis. The main factor determined adsorption properties spinel to lithium ions were studied. Lithium manganese spinel solvent prepared by salt gel method had higher adsorption capacity and removal efficiency. First studies of lithium manganese spinels will be aimed to dope with transition metals ions, which may lead to an increase in the stability of crystal structure during multiply adsorption-desorption cycles. Thanks for attention.
Any colleagues? Maybe somebody wants to ask questions. Unfortunately, we had no full success to watch all screens. Anyway, thank you, Daria. Thank you for your proceed.
Yeah.
Have a productive work in the future. Our colleagues, I think I'm the last moderator of session B. Thank you for this opportunity. Thank you to everyone who was with us all this day and yesterday. This is so sorry to know that we are online only, but anyway, we are with you in our mind. Take care. Thank you and bye-bye.
Bye.
Maybe you can watch your faces and we will make a big screenshot with your faces. May you switch on your cameras? Коллеги, включите микрофоны. Свои камеры включите, мы сделаем скрин. Ладно. Спасибо. See you.
Thank you.
Mulțumesc mult.